What is up, everybody? Welcome to the stream. What is up, everybody? Oh no! I didn't mute that other thingy. I love it when I forget to mute the other thing. How are we doing, everybody? Welcome to the stream. Just lower that a little bit. Alright. It's your friend, it's Joe. How are we doing? Got my little crown on, got my mustachio on, got my glasses ready to go. My goofball. Alright. Let's get into it, folks. Let's hit this hard and heavy. We got some work to do today, guys. We got some work to do today. Yeah, we do. All right. So, like I was talking about yesterday, let me just make sure that this doesn't poop the bed. All right. All right. So, share. Just like we were talking about yesterday, guys. We're gonna be doing a big chapter, a big review today. We're going to be going from chapter 1 all the way to chapter 21 as of where we are at currently right now with the with our studies. So, excusez-moi, s'il vous plaît. We got the Pearson test product up. We're going to be hitting ourselves with the big old whopping, the big whopper today to kind of rack our brain a little bit. This needs to happen. This is a continuous process that I need to continue to do. I would love for you guys out there in the chat and in the stream to follow along with me and help give input and stuff like that. When questions arise in chat, for those who out there who are knowledgeable about what we're covering, please I invite you to chat it up in chat and give your input to the others in chat. Help out, answer questions and stuff like that. That way I don't get too bogged down with trying to answer questions and stuff like that. But I invite questions as well. You know what I'm saying? I love answering questions. I invite you guys out there to quiz me and continue to rack my brain. It's something that I find priceless and invaluable. You know what I'm saying? I hope you understand. I know you guys understand what I'm saying. So we're gonna be using Cisco Packet Tracer today. We won't be using Cisco Modeling Lab just for the present for the. So what I'm looking for, just to preserve time, I guess. You know what I'm saying? Because what I want to kind of do. And I got Discord up and stuff like that. And what I want to kind of do is, if we start hitting some sticky areas, to jump over to Cisco Packet Tracer, lab it up. You know what I'm saying? It is obviously going to be faster for me to lab it up in Packet Tracer than it would be for me to lab it up in CML, just because of the time it takes to boot up those virtual images and whatnot. So we're gonna be up on the Packet Tracer today. The good thing about Packet Tracer, again, I put my Discord in chat again. If you join the Discord server and go to the Cisco Packet Tracer channel there that I have, and you'll see me. I'll be populating Packet Tracer labs and whatnot. I'm gonna be doing that with Cisco Modeling Lab and stuff like that. Obviously, you'll have to have Cisco Modeling Lab because it'll be an XML file that you'll download for the lab and stuff like that. But you'll have to know how to import that into a Cisco Modeling Lab itself. So that would be coming. What I was gonna do that through GitHub, and I still might do it through GitHub too, just to populate things in my on GitHub and whatnot. I might make like a webhook that when I populate it to when I load it up to GitHub, it'll hook back to my Discord server. So that'd be something I'll probably work on too. But yeah, so we're gonna be like I said, we're gonna be using Cisco packet tracers today. I'll have to update my little thingy-maboober that says Cisco Model and Lab. I'm gonna have to make a couple extra scenes on my streaming software there. That way, I can get like zoomed in scenes when I'm working on the command line and stuff like that. And I apologize and thank you for bringing that up too, chat, about my viewer count being in the way and stuff like that. I honestly, it's funny because I have so many. I've been making so many different like different themes and stuff like that with the streaming software that I've been using. It's funny because I should just revert. There's the word, revert back to one of the original ones that I had using before, because I had it set up real nice where I had zoomed in scenes and scenes to go back and forth. But you know, I've been trying to keep I've been trying to keep it fresh by keep updating it and how it looks and stuff like that. That might just be a thing that I keep doing. You know what I'm saying? I'm one of those that I just can't. I just can't settle. Nothing's good enough. I have to keep touching things. That's just part of my personality, I guess. Let's see. Let me just make sure everything's working good. Yeah, everything seems to be working good. All right. So, yeah. Just finish on my coffee. How's everybody doing today, though, in chat? How's everybody doing? Hope everybody's having a good day. Today's me and the wife's 13th year anniversary. Whoop, whoop. Shout out to my wife if she's listening. Yeah, I'm a bad husband. We didn't get time to really go on a date or anything like that. Obviously with everything going on with the restrictions and lockdowns, and her schedule is different than my total different schedule now, and everything else. So I got her something today though, that she liked. That she's been wanting for the longest time. She's been wanting a Keurig, the Keurig Duo, so she can make like a craft the coffee and have the ability to use the little Keurig pods and whatnot. So I got her one of those today to surprise her. So she loved it. So there's my little anniversary gift. Yeah, 13 years of marriage, guys. Woo! Man, I tell you, it went by fast though. It went by fast. It was, I can remember like it was just yesterday when we had met, and we met. We met and got married pretty fast. We met 2 weeks later. We end up getting married at a chapel, and then I got I got the call to go to boot camp, and I was gone for about it was about 9 months because of my advanced training after boot camp. So that was pretty funny. But no, we've stuck it out together. 13 years. What's another 13 years? I'm enjoying her Keurig, as you can tell too. I still gotta get another kettle because my kettle is my daughter melted it the other day on me. Whatever, kids do crazy things. All right, let's get over. And you know what I'm going to do? I need to switch a U. No, not 2. Shadow 1. There it goes. A packet. There we go. All right. Gotta stop touching things or work it like I always do. All right. That's good. Yeah. All right. I know it's not Cisco Packet Tracer right here. This is the we're gonna be using, like I said, we're gonna be using the Pearson test program, and we're gonna be doing the big Mamma Jamma one today. Getting notifications are crazy. Okay, so we're gonna do the full gambit. And we're gonna be doing from chapter 1 all the way to where we're currently at with OSBF at chapter 21. So this ought to be a big big test to really mess me up. Well, to break my brain at least. No more than, we're gonna say, how many should we do, chat? Should we go with 200 questions to really spend some time on this? Let's go with 200 questions. Randomized questions, randomized answers. Question types, yep. We're going to keep it in study mode too. Study mode, it'll give you the explanation if we get it wrong. And it'll tell us right away when we got it wrong too. So you guys be able to see that too as well. So. All right. Finish up my coffee. I got a Red Bull just in case I start getting tired, but we did pretty good. You guys pumped me up. You guys really pumped me up yesterday because I was feeling, boy, was I feeling tired yesterday. But after everybody started flooding in and stuff like that, you guys pumped me up, man, and brought my energy levels up. You guys are amazing, FYI. You guys are getting me through this. I'll tell you that much. If it wasn't for you guys out there, I tell you, I don't think I would be as far as I am. I don't think I'd be as far as I am with these studies, honestly, guys, if it wasn't for you guys out there. You know what? I'm gonna put up Twitch on this. That way I can monitor chat along with you guys a little bit easier and better. Slow with that. I'll put this up here. We're gonna transition over to the whiteboard, guys. I feel as though it's better. I do better when I'm on the whiteboard. That way, we can also do some explanations and draw out stuff too as well. When I'm on the whiteboard, I'm just gonna make sure the whiteboard scene is still good. It is still okay, but I want to move the viewer count. I'm gonna make that a little bit smaller, guys. Still want to keep it, but I want to make it smaller. Yeah, we can put it up there actually. That way, it's not being too intrusive. All right, and move it just a little bit, make it straight. All right. If that gets annoying, guys, just give me a shout. And again, I want to thank you all the other day for calling me out on that it was in the way of the it was in the way of the stinking not the stinking, but it was in the way of actually seeing the command line. So thank you guys out for calling me out on that yesterday. I appreciate that because I wasn't paying attention. Obviously, I wasn't paying attention. So, all right. Let's clear up the whiteboard real quick. Let's give it a quick clean before we start the test. Again, this is going to be a big review, and my brain's going to get hurt. My poor little brain. My poor little brain. All right. Just wipe it down. It doesn't have to be perfect. I just want to make sure it's somewhat clean. Gotta get something. I got some index. Not too much. Not too much. All right. I gotta get more. I gotta get some more dry erase markers, guys. I'm running out of them. Get them pretty cheap off of Amazon. It's pretty neat. I can get a box of them. That's what I did last time. I got a box of them for like I don't know how much was it, like $10 or so. It was fairly inexpensive. There we go. Stop moving, monitor. All right. Get my handy schmandy thingy on. There you are. There's me mouse. All right, I'm monitoring chat. I can see chat. I got my stuff over there. Ooh, I need my dry erase markers. And we are ready to go, guys. Okay. All right. We're ready to go. We got everything ready. We're going to do about 200 questions. I got my calculator just in case I run into any subnetting questions. All right. Let's get ready to run. Oh, I don't want to say that because I'll get in trouble for that. Things are getting crazy on Twitch, guys. It's for real these days. All right. Stop complaining. All right, let's do it. All right. How many questions? Ooh, we got 155. Woo, boy. We're going to get beat up. All right. You have to blast through a lot of these, though. Pretty fast. Stay there, monitor. All right. All right. The term segment refers to which layer PDU. All right. So remember in the OSI model, that would be the transportation. Okay. So that's the fourth layer. The fourth layer. Okay. We have obviously network at the third layer, and then transportation at the fourth layer. All right. All right. A user has sent a request to the server. What process does the server go through to determine what service is being requested by the user? So we have de-encapsulation. It's got to open up. All right. It's got to open up that that frame there, that packet, and see what it's doing. All right. See what it wants, pretty much. All right. Which of the following terms represent a layer 3 PDU in the OSI model, which includes the network layer header in its encapsulated data? So we have a packet. Okay. IP functions at which layer of the OSI model? Pretty much just like what I just said, network. So we know this is this output comes from a network analyzation tool like Wireshark or something like that. All right, so it's just showing us a frame. All right, and it's showing us the data within that frame. Let's take a look at what we got. In describing line A from the graphic, which with an OSI model perspective, what is the correct label to be used in combination with that PDU? All right, so we have his we have line A right here. All right, so we're going to be taking a look. So this is the layer 2 information, obviously Ethernet 2, some source. So this was the source MAC address, destination MAC address. All right, destination. All right, 000, source again. All right, and then it's just so type. So this is the type field right here. All right, and it's just saying type IP, and then you have the type number right here. So this would be this is describing IP as the type. All right. All right. So we have, what's it? Not segment, not packet, not bit. Frame. Yeah. All right. All right. Let's keep it going. Based on the packet capture, which of the following is true? All right. Let's take a look at what we got. Line A is used for logical addressing, routing, and path determination. Nope. Line C, information to use to route packets. through the internetwork. That's the trend. This is the transmission. So no. Line C corresponds with the transportation layer of the TCP/IP model. Yes, it does. Line B is used for connections to establish termination flow control segment large data. Line B is formatting data. Appropriate transmission. No. All right. So we have line C. Line C corresponds to the transmission control protocol. Transmission control protocol, which is the transportation layer. Okay. All right. From the output of R1, which of the following is accurate? Ooh, let's take a look. See. So we have show address resolution protocol ARP. All right. Let's take a look at what we got from the output. R1 has learned the IP address of 10.0.0.1 in less than 1 minute. R1 is will use the address layer 3. Nope, that's layer 2, buddy. That's the MAC address. The address of the obviously the MAC address is designed to assign a single network interface card and never duplicated on a different NIC. Pretty much. We need some unique MAC addresses. The hardware address field represents a 32-bit layer. Okay, let's just go with the MAC addressee. All right. Refer to the diagram. The new connection that is going between campus 1 and campus 2. Router requires to provide 500 megabytes per second of bandwidth. The router are located 3,000 meters away from each other. Which standard of Ethernet should we be using in this situation? Again, let's think big. All right, so we need to think big. When we think big, we think Zulu. All right. The network in this figure uses Cat5 cabling with RJ45 connectors. Which of the following statements are true about the wires inside the cabling and the RJ45 pins to which they are connected? Okay, so let's remember some of the logic. So remember, when we get back to logic here, PCs, switches. So let's put PCs, and then we use switches or bridges on this side. So when we think PCs, we also have routers too over here, and then we have access points. Okay, so we have bridges. All right, and then the awful one that everybody beat me up about yesterday, we have hubs. We have hubs over here too. All right, so when we connect PCs to switches and bridges and hubs, all right, so we're using straight through cabling. All right, straight through. All right, but when switches connect to bridges, all right, we're using crossover cabling. All right, crossover cabling. All right, and that is because of how they're transmitting. Okay, so on pin 1, we'll just say on pin 1 and on pin 2. So we'll pin 1 and pin 2, pin 1 and pin 2. All right, one is receiving and the other one's transmission, and then it's completely opposite on the other one, where this one is transmitting and this one is receiving. Okay, all right. But what happens is if when we connect a bridge, a switch or a switch together, or a bridge, a hub, a switch to a hub or whatever, they're transmitting on the same one. All right. So it's receive and then transmitting and then receive. So they're transmitting and receiving on the same pin. So we have to cross those over. So it'd be obviously the transmission be going to the receiving, and then the receiving to the transmission. Okay. So that's the type of logic that we have there. All right. So we got to select 2 answers. All right. So the cabling from PC1 to switch 1 connects to 6 and 3. Nope. The cabling from PC1 to switch 1 connects to 2 and 3. Nope. The cabling from switch 1 to switch 2 connects on 2 and 3. No, because pin 1 connects to pin 3 on a crossover cabling, and then pin 2 connects to pin 6 on a crossover cabling. Okay. Oh, that one's right. Yep, we just talked about that actually. The cabling from switch 1 to our router 1 connects on pin 6 and pin 6. Yep. And then, cool. All right. In the figure, Cat5 cabling with RJ45 connectors, which of the following statements are true about the cabling, the wires inside the cabling, the RJ45 pins in which they are connected. So it looks like we only have to select one answer. The cabling from switch 1 to switch 2 connects on, nope. The cabling between switch 1 and switch 2 connects on pin 6 and pin 3. Nope. The cabling between PC1 and switch 1 both connect on pin 6 and pin 6. Yes, they do. All right. Keep it moving. The network in the figure uses Cat5 cabling with RJ45 connectors. Which of the following statements are true about the wires inside the cabling, and the RJ45 pins to which they are connected. Okay, we're looking for 3 answers now. Okay, woo-hoo. All right. The cabling from PC1 to switch 1 connects to 1 and 3. Nope. The cabling from PC1 to switch 1 connects to pin 1 and pin 1. Yes, it does. Straight through cabling. That's what we want. The cabling from switch 1 to switch 2 connect on pin 1 and pin 1. Nope. Switch 1 to switch 2, 1 and 3. Yes, it does. Remember, remember 1 and 3, 2 to 6. Okay. The cabling from switch 1 to switch 2 to R1, 1 and 3. Nope. And then the switch 2 to R1, 2 and 2. Yes. All right. There's our 3 answers. All right. The diagram refers to which type of fiber optic cable. Remember, when we have a larger diameter of the core. All right. When we have a larger diameter core here. All right. That's allowing the light to be refracted off of the cladding. The cladding here, okay? The cladding here, all right? The cladding is like some reflective type material. So when that light gets transmitted through here with that larger core, that light is bouncing and reflecting off that cladding, okay? But if we have a smaller type core, all right, we still have cladding, all right? But that light is being shut straight through that core because that core is super, super small at that point. And it doesn't allow for it to bounce around like that. So we have multi-mode here, all right? Multiple mode. All right. Welcome, everybody. Here's another output from Wireshark, okay? The circle part of the Ethernet frame lists the hex 0800. Okay, remember 0? We looked at this earlier when we were looking at that other packet. Okay, so that's the type field, and it's identifying IP. Okay, it's identifying IP. All right, so we're going to be looking at type. All right. All right. Which of the fields are in the IPv4 header? Okay, which of the fields are in the IPv4 header? All right, so we need to select 3 answers. So we have destination port, protocol, not destination port, psycho. Yes, destination port. Yeah. All right. Yeah. All right. I knew it wasn't destination port. Destination port, that's layer 2 stuff right there. Woo! Almost had a brain fart for a second, guys. I'm glad I caught myself at the very end. I'm just clicking at this point. Stop doing that. All right. You guys gotta like rack me back in when I get too hold on, I try to get too fast sometimes on these. All right. A device uses MAC address. Obviously, you see the MAC address here. 46 echo echo. Which part of the MAC address indicates the originating orienting network equipment vendor? Okay, so that would be, so if we were looking at the MAC address here, it would be the first half. Okay, so the first half of the MAC address here. Okay, so we have 00 Charlie 42. All right, that would be our answer. Okay, 00 Charlie 42 here. All right. All right, so the first half of the MAC address, okay? First half. All right. The diagram shows a simple internet network in which all local area connections use fast Ethernet. Select the answers that list the correct cable and type. So another cable in question. Very cool. All right, crossover cable between switch 1 and switch 2. Whoa, that was easy right off the bat. We got one. All right. A Ethernet crossover cable between, nope. A Ethernet crossover cable between switch 3 and hub 1. Yes, it is. All right. Boom. We got that. All right. Which of the following data link protocol used to encapsulate data on a leased line? So we have point-to-point and HDLC. Okay. High-level data link control and point-to-point. Okay. Which of the following are Ethernet WAN services? So we have E-line. All right. And we have Ethernet over MPLS, okay, Ethernet over MPLS, Ethernet line service, okay. All right, a host at 10.3.0.1 powers on a device and issues the ping to 10.3.0.2. All right. What is true about the address resolution protocol sent by 10.3.0.1? We have to select two answers. This is part of the DNS. No. The frame will be de-encapsulated only by the device. The host 10.3.0.1 is attempting to learn layer 2 address. Yes, it is. It's trying to learn what is the layer 2. We need some layer 2 information here. That's what pretty much ARP is trying to find out. All right. The device processing the request will reply with the unicast address with a unicast frame from the host. Yes, it will. All right. Based on the diagram, host A sends a packet to server B. The two serial links use HDLC, high-level data link control, while the rest are Ethernet. How many times does that packet experience re-encapsulation by a router? All right, every single time it hits a router, it's going to get de-encapsulated and re-encapsulated again. Okay, it doesn't matter if it's going over Ethernet or point-to-point HDLC. Every time that frame is hitting that router, it's being de-encapsulated because that router wants to know information about that layer 3 packet inside of it, that IP packet. Okay, so what do we got? So it's going to hit here. Okay, it's going to get de-encapsulated, re-encapsulated, and sent out. It's going to do the same thing here, same thing here, same thing here. Okay, so what do we got? 1, 2, 3, 4, 5. We got 5 times. All right. A lease line provides what kind of a service? So a lease line, this question got me one time before. A lease line provides what kind of a service? All right. It is a layer 1 service. A layer 1 service. It's an actual physical cabling. Okay. All right. How does the receiver of a HDLC frame know what has been encapsulated within the frame? The type field in the header. The type field in the header. Which protocol finds an unknown layer 2 address from a known IP address? Okay, just like we were talking about before. Address resolution protocol. It wants to find out that layer 2 information of a known IP address. Okay. All right. In the figure, all devices are statically configured with IP addresses, mask, and default gateway information, assuming that all switches and PCs have completed reload. The switches, the switch max address tables are empty. The PCs tables are empty, and none of the PCs or the routers have sent the frame out. Which of the following are true? Okay. All right. So what do we got? When PC1 pings PC2, so PC1 pings PC2, the first frame will be the ARP request. That sounds pretty good. Let's just read some of the other ones. When PC1 pings PC2, the first Ethernet frame will be a broadcast destination address. When PC1 pings PC2, the first frame will have R1's, no, because it's not even going to go. I mean, it's not going to, the router is not going to route that back to PC2 here. How's that? All right. When PC1 pings PC2, the first packet will be an ICM echo request. No, it won't, because it's going to be an ARP. All right. It's going to be looking for PC2's. It needs to know PC2's layer 2 information. When PC1 pings PC2, the first Ethernet frame will have PC2's MAC address as the destination MAC. All right, but it doesn't know it yet. So we're going to be saying that on ARP first. All right, and then the first frame will have a broadcast destination address. All right, I feel pretty comfortable with that. All right, because you got to remember, when we got to find out. We don't know exactly where PC2. We might know PC2's IP address, but we don't know exactly where it is yet, and that's why we need to find out. Because you got to understand, when that ARP request hits that switch is also going to broadcast that that frame out to everybody, okay? It's going to broadcast it out to everybody, and it's going to be sending that ARP request out to everybody, la-di-da-di, and that ARP request is going to be asking everybody, okay, who is at, 10.0.0.1 or 2, whatever, and everyone's going to be replying, if it's theirs, they're going to reply back. And obviously once PC2 gets it, it's going to say, oh, this is my IP address, and this is my layer 2 information. Now let me send that request back, okay? And it's going to be sending it on a unicast address back, all right? What exam is this? What's up, Maraduck? You the man. This is the Pearson test prep. That's what I'm using right now, my good friend. Good looks on that question today too, my friend. That was pretty good. I like that, what you put in the Discord. Keep that up. I was honestly thinking about that crazy Joe bot that I got in that server there. I was thinking about maybe automating something like that. So if you get an idea about something like that, hit me up about that, because that was pretty neat what you put in that question you hit me up with. But yeah, so everybody in chat today. So we're using the Pearson test prep software today to do this big review that we're doing right now. All right. If an engineer issues the copy running config startup config command, which Cisco memory type would the configuration be copied to? Okay. So remember, when we're actively inside of a networking device and we're doing commands and stuff like that, that's just being saved to RAM, okay? But to make sure it gets saved for when we reload that device, okay, we have to save that to our NVRAM. So when the engineer runs the copy running startup config, it's saving it to the NVRAM, okay? All right. Using a cable to connect a Workbench PC to the console port of the switch, you notice that the switch is non-responsive. A co-worker mentions that the same PC was used with the same switch early in the day. The SYST LED light is green, saying that it's on. Okay, so you have power to it. Consider this given scenario. What should the technician do? We got to select 2 answers. Okay, this is a big thing. Is always when these types of questions. You're always going to make sure you have the amount of questions you need to select. Okay, so verifying that the correct physical connection has been made. That sounds pretty good. Make sure that the cabling is a rollover cable. That sounds good too. Check to see if the cabling is using a Cat5 or verify that the cable is crossover. Nope. Verifying the straight through. Nope. All right, so we have our 2 right here. So we want to verify the physical connection has been made, and we got to verify if we're actually using a rollover cable, guys. All right. What is the name of the Cisco iOS command line exec mode that allows a user to run more powerful commands? So we're in enable mode, all right? Enable mode, all right? If an engineer has completed a series of changes to a Cisco switch and wants to ensure that the changes are saved and retained across reboots, which command would you issue? So that'd be the copy running config startup config. Copy running config startup config. All right. I know you guys, when you guys see me on the the various programs that I've been using, you see me do the do right, all right, or the R or the WR. That's just the shorthand of the copy running config startup config. All right. All right. When the Cisco iOS command line is initially accessed via telnet, the console telnet SSH with no extra privileges. Now remember, you could set the login privileges as well to go straight to enable mode too. We covered that a while ago. All right, but with no extra privileges, what mode would the user be placed in? So you'd be in user mode. Okay, user mode. Copy, run, start. Copy, run, start. What's up, Para? How we doing today? All right. Your switch is in an air-conditioned locked wiring closet on the first floor of the building. There is a card on the door that allows only authorized personnel in the room. On Thursday, you issued you use Telnet to connect to the switch and issue the following command: host name, switch W1 and log out. So you can see the original host name, boot mode. You're going to be in user mode, not boot mode. User mode. So you can see what the engineer did. So they changed the host name here, okay? But what didn't they do? What didn't they do? All right? They didn't save this actual configuration to their NVRAM. He logged out, and he didn't save it. All right? So, here we go, show version, yada, yada, yada. Yep. All right, so based on the output, what is the cause of the state of the host name for the switch? You forgot to use the command. Nope. You forgot to commit the changes and automatically roll back. Nope. You forgot to save the configuration. It's all good. It's all good. You know what? This is what it's about. So this is all about reviewing, my good friend. And if I'm going too fast, just tell me to slow down, guys, okay? If I'm going too fast, just tell me to slow down, all right? Because I want you guys to be just as a part of this review as I am too, okay? So, again, if I go too fast, just tell me, okay? So the engineer, they never saved what their configuration was. They never saved it to NVRAM. Because, again, remember, when you're doing these configurations, everything is being committed to RAM, the active. So RAM is the active memory that these configurations are being saved to. So that configuration file, remember, it's just like a text file, that's just being saved to RAM. And if you don't commit that to the NVRAM, if that switch was to go down or reload or anything else, NVRAM is what's part of that original, is part of that booting system that boots up the network device there. And if it doesn't have that text file saved in it, it's just going to reload whatever configuration file it has in it. By the way, when working with Juniper, you have to commit the changes you make, or they don't take any effect. So yeah, so that must be very similar to how these Cisco devices are working as well. Yeah, that's so if anybody's in chat, note that as well if you work on Juniper. All right, very similar as well. All right, refer to the diagram. Which of the following connection parameters are used when connecting to the console of a Cisco switch? Which of the following connection parameters are used when connecting to the console of a Cisco switch? All right, so what do we got? What's that saying I always do, everybody? What's up, called PGP? How we doing, my friend? So, what's that saying I always do? 9600, 8-in-1. 9600, 8-in-1. So if you're using, PuTTY or some kind of console emulator or something like that, you're going to be entering the 9600 none 8-in-1. All right, 9600 none 8-in-1. All right. I try not to use Juniper if I can help it. I have no. I think I've mentioned this. I haven't had any experience using Juniper or anything like that just yet. I hope to, just dabble in it. All right. What is the default aging timer for a MAC address table entry that have not been used? All right. So we're going to be looking at it for 300 seconds. There we go, Par. 300 seconds. You're on it. You know it. All right. What type of memory does the switch use to build its MAC address table? All right. What type of memory does the switch use to build its MAC address table? So there's another type of memory that this is being saved to. Whoop, whoop. All right. So we're going to be saving it all to our TCAM. All right. Our TCAM. All right. All right. What will a switch compare in its MAC address table to be able to forward a frame? All right. I like the ice cream. Everyone has their flavor. Oh, it's like ice cream. Everybody has their flavor. I like that saying. All right. What will a switch compare its MAC address table to be able to forward a frame? All right, it's going to be looking for destination MAC address. Destination MAC address, okay? Because what it wants to do, if it's already learned, say, so switches, they learn they're only when they're learning MAC addresses, they're only learning the sources. Okay, so when a frame comes in, they say, okay, this source MAC address came from this port. Okay, so when I get another frame in, it looks at its MAC address table and say, okay, I've gotten this MAC address that I'm getting now out of this destination. I've gotten this MAC address before out of this port. Okay, so I'm gonna forward it out of that port to that destination MAC. All right. After power on, a frame receives. After power on, a frame arrives at the switch. The switch has not learned the source MAC address of that frame. What action must the switch take in this case? Okay. Switch adds the destination. Nope. The switch checks for frames in the for a loop. No, not really. The switch adds the source MAC address. No, it doesn't add the destination. The switch adds the source MAC address to its MAC address table. Exactly. So again, it just wants to know the source. When it's learning MAC addresses, it just wants to learn the source MAC addresses and out of what port did that come from. So we're going to select that one right there. All right. How does a switch build its MAC address table? Okay. By listening to incoming frames and examining source MAC addresses, by listening to outgoing frames, by listening by listening to incoming frames and examining the source MAC address. Okay, by listening to incoming frames, again, the frames come in, it sees the source. If it doesn't have that source MAC address in its MAC address table to a certain port, it says, okay, I've learned, I'm gonna record this in my MAC address table, and I'm gonna record the port in which it came in from. Okay. All host ports reside in VLAN 1 with no port security, no static MAC address table entries defined. Host B remains powered off, but all other hosts can ping each other successfully. Later, host B powers up and the user issues the 10.1.1.4 command to generate host B's first network traffic. So host B hasn't generated any, it hasn't learned anything, it hasn't generated any traffic yet. So host B has been completely off this entire time. It's almost like host B wasn't even connected to this network, okay, until it just powered on. All right, so let's keep that in mind. All right, which answers describes a frame forwarding in this situation? So we got to select two answers. All right, so there's host B right here. All right, so host B is going to ping 10.1.1.4, which is right here at host D. Okay. All right. So the frame will be forwarded to host D. Yes, it will. Okay. So we're going to select that. It's definitely going to go to host D no matter what. But we're going to select one more answer. Let's find the other answer. The frame will be forwarded to S2 but not S3. No, it's going to go to everybody at this point. The frame will be forwarded out, switch gigabit 0-1 interface. Yeah, it will be. The frame will not be forwarded. It's going to, again, that frame is going to go to pretty much la-di-da-di. Everybody's going to get a copy of this frame coming from here. So the frame's going to go here. It's going to go out that switch. All right, it's going to come here. It's going to go here. It's going to go here. All right, everybody's going to get a copy of this frame. All right. All right, because it's going to be flooded to everybody, la-di-da-di. All right, in the figure, all devices are statically configured with IP addresses and masks and default gateway information, assuming that all switches have learned all the MAC address tables and of all the devices. PC1 pings PC4 and PC receives the reply confirming that ping worked. Which of the following are true about the frames sent in this network and then encapsulated packets? When considering a frame, consider the header and frame in any encapsulated packet as well. Oh boy, it's going to be a nice one. All right. So what do we got? What do we got? Let's look at some information. All right. So we got PC1's info, and we got PC4's info right here. All right. So it looks like we're going to be traveling, obviously, from these switches to this router here, and then out the router, and then obviously we're going to be getting that reply back, and then that reply is going to be going back. All right. All right. Frame containing the ICMP echo request sent by PC1 has the destination IP address of 10.1.1.254. Nope, it does not. All right, it's actually stating that it's going to have the dest of the router 1, which it's not. All right. The frame that contains the ICP echo request sent by PC1 has the destination MAC address of R1's 500's interface. Ooh, that sounds pretty. That might be the case. Let's continue to read on, okay? We have a lot to, we got to select 2 of these answers too. The frame that contains the ICP echo request reply sent by PC4 has the destination MAC address of the, so the reply sent, all right, has the destination MAC of 5.0's interface. Ooh. All right, the frame that contains the ICP echo reply sent by PC4 has the destination MAC address of PC1. Nope. Let's actually, let's do this. Let's just cross out the ones we already know it's not going to be. So we know it's not going to be this. All right. The frame that contains the ICP echo request sent by PC1 has the destination MAC address. Yes. So I know it's this. The frame that contains the ICP echo request sent by PC1 has the destination IP address of PC4. Yes. We know it's going to be that. The frame that contains the ICP echo request sent by PC1 has the destination MAC of PC4. We know it's not, so it's not that. Okay. All right, because you gotta think when that frame gets to this router here. Okay, that router is going to de-encapsulate and then re-encapsulate that IP packet inside of a new frame. Okay. All right. So let's read these other 3 top ones real quick. The frame that contains the ICP echo request sent by PC1 has the destination, so we know it's not that one. All right, so we have 2 more. All right, so we got to select from these 2 right here. The frame that contains the ICP echo request sent by PC1 has the destination MAC of the FA. No. Right? For yes. The frame that contains the EXO reply sent by PC1 has the destination MAC. All right. So what it's stating is when PC1 sends it to PC4, is it going to have the destination of the FA0 going this way? Is it going to have that as the destination of that? Or when it sends it this way, is it going to have the dest? Frame contains the answer has the destination MAC. Oh, wait. I'm reading this wrong. So when PC4 sends that reply back, it's going to have the destination of FA. All right, I was reading it wrong. It's going to have the actual destination of FA001's interface, okay? But when PC1 sends that ICP echo request, it's going to have the actual destination. Okay, very good. So we're going to go with this one right here, guys. All right. So let's select that one. Yeah. Frame that contains the ICP echo sent by PC1 has the destination. Yeah. All right. We're going to go with that. All right. Boop. We were good. All right. All right, let's continue on. All right, all IP addresses are configured for PC for the PCs, and they are correctly connected to the network. The MAC address table on the switch looks like this. All right, so what do we got? We got four. We got PC 1, 2, 3, 4. All right, we got 111, 222, 444, 111, 222, and 444. So PC 3 doesn't look like PC 3 here. It doesn't look like its MAC address has been learned yet. Okay. All right, so let's keep that in mind. PC 4 has the layer 2 address of PC 3 in its ARP table. PC 4 sends a unicast ping to PC 3 as shown in the packet capture. Yeah, we know that. So this is just stating that this came from like Wireshark, whatever. What will the result of the ping? All right, so they're in two different VLANs here. All right, it looks like we only got to select one answer. The switch will reply to the echo request with an echo reply. The switch will flood the frame. It's not going to flood it to another VLAN. All right, because you got to think this is on its own broadcast domain. This is in its own broadcast domain. Okay, the switch will flood the frame to PC3. It is going to actually flood it to PC3, even though we'll say switch 4 has the layer 2 information for PC3. The thing is that the switch doesn't have that information, so it's actually going to flood it. All right, switch will filter the frame enough water. So let's go with the switch will flood it to PC3. All right, we're doing pretty good. All right, a local user Bob has been created on the switch, and the following output is from the same switch. Okay, so show crypto key my plug RSH. All right, so we have a domain. Here is our SSH key right here, a public key, our domain key, encryption, yada yada yada. Okay. Bob has an IP address on his computer and can ping the interface of the switch. SSH is enabled on the VTY lines, but the user Bob cannot log into the switch via SSH. What will need to be added to the configuration? Nope, it has a domain. The SSH key has been generated. Localhost authentication, that could be right. All right, so let's go with localhost authentication, because what I'm not seeing is I'm not seeing anything for user Bob or password on that one. All right, so in the figure, the 2960 switch has been taken out of the box and cabled. And the PC2 can communicate through router 1 with the rest of the IP network. However, no configurations has been made to either switch 1 or switch 2. So either switch 1 or switch 2. All right. As a result, the engineer sitting at the management station to the right of of R1, to the right of R1. There we go. This is our engineer right here. All right. Cannot telnet to switch 2. Okay. What is the following configuration command when entered into the correct order of switch 2 allows the network engineer to ping or telnet to switch 2. All right. Communicate. Yada yada yada. Okay. So these switches have been just pretty much dropped. Have just been dropped inside the network. Okay. So they need a couple things. They need IP addresses. They need that IP address to be assigned to a management VLAN and stuff like that. All right. So we also our default gateway would be 10.1.1.225. So IP default gateway. We need an IP address. What's our IP address on? So we have 10.1.1.200 at 255.255.255.0. That looks good. The node shut, and then interface VLAN 1. All right. So there's our configuration. So the engineer can actually be able to ping and then telnet or SSH. Well, if they configure, hopefully they configure SSH on this switch. That way, Bob the hacker can't hack into it later on. All right. All right. The exhibit shows some configuration commands that sit in a text file. After adding this configuration to a switch, the user will attempt to connect with username Fred and password Hope. Which of the following describe the accuracy of the configuration for allowing a user attached to subnet 10.1.1.0/24 to SSH to use SSH to connect to the switch? All right, so we have a host name, we have a domain, we have user Fred and Hope, user and password Hope, crypto key generate, modulus 1024. So they've created the crypto, the SSH key, IP interface VLAN 1, IP address. So they've configured a management VLAN with an IP address. They gave it a no shut command. Very good. And they've logged into the line VTY 0-4 and boop. And then there's one of our problems right there. They gave it the login, okay, but they didn't give it the login local. So it's not going to recognize the user and password combination, okay? And then obviously they gave it the transport input, telnet and SSH, which is fine and dandy, but they didn't give it the login local, okay? So it's not going to actually recognize that that user and password combination there, okay? All right. Select two. All right, so we got to select two instances. An engineer logs into a device to perform some troubleshooting. The engineer expects to need to repeat. The engineer expects to need to repeat many commands. So he wants to use. Ensure that the device remembers the commands in the device history buffer for easy recall. What command would be used to ensure this behavior? So the engineer is looking like the engineer is going to be, making. Using that same command over and over and over and over again. So he wants to be able to make sure that the history size is pretty big. So we're going to be over in enable mode and configuration line mode. So terminal history size, then history size 9 line, number line. There we go. Let's go with that. All right. Which answer encrypts the password that will be required of a user after they type in the enable exec command mode? Which answer encrypts? So remember, encrypts. So we have the enable secret command. The enable secret command. All right, that encrypts the password required to go from user mode to enable mode. All right. Now remember, you can set that password, but it's going to come up as clear text. All right, in your running configuration. All right. So unless you enable the enable secret command, that password value will always come up as clear text, okay? All right, which command will generate an SSH encryption key? So remember, crypto key RSH, RSA, not RSH, RSA, crypto key RSH. All right, I keep saying H, A. Crypto key generate RSA. All right. All right. As an administrator, you decide to change the password periodically on the switch. You enter the following command: enable password Bubba123. The next time you tell that to the switch, you are prompt for a password, but Bubba is not accepted. Why is Bubba not accepted? Okay. Looks like we're just looking for one answer. We should have been in line configuration mode before using the command to enable the password that was set. The enabled password that was set was not is not in the VTY line password. The telnet protocol, the enabled password. So the password here, okay, the password that was set is not the VTY line password. Password that was set is not in the VTY line password. We should have been using the line configuration mode before using. We should have been in line configuration mode for using this command, the telnet. Oh, yes. So the enable password that was set is not the VTY line password. So pretty much what that's saying is that administrator should have then went into line VTY line mode, okay? All right, and then use the login local command, so that password would be accepted on the when they would log in via Telnet SSH or what have you. Woo, we got some cat with some glasses. All right. Which two of the following actions provide the best security for accessing a router privilege mode remotely? Okay. Enable SSH and disable Telnet access using the transport input SSH VTY line. Yep. And then configure the enable secret command. Yep. Nope, that's wrong, and nope, that's wrong. Okay. This transport input Telnet and SSH, that will allow Telnet and SSH, both of them. Okay. And the enable password. Remember, the enable password that comes up as clear text in your actual configuration file. All right, refer to the diagram. Both switches are Cisco switches. All right. What would be the state and speed in duplex of the links refer to the switch 1? Okay. What do we got? Switch 1, auto negotiate fails because switch 2 does not using it. All right, and that is because a engineer went inside and then configured the speed in duplex manually, statically. All right, they set it to speed 1000 and duplex full. All right, but switch 1, even though auto negotiated has failed, all right, it's going to still be up with 1000 and full. Okay, all right. All right, refer to the diagram in the exhibit. Which of the options is a potential reason for the interface status shown for the Ethernet interface shown in the figure? So what do we got? We got a kind of a mismatch of speeds here. So we have a fast Ethernet, and we have a gigabit Ethernet between the two routers. Okay, we have a mismatch. Let's go with, we had to select 2. So let's take a look at the, what are the interfaces again? So we have 0, 0 and 0, 0. Okay. All right. So it's down. It's down, okay? So there's actually might be something, the protocol is not even taken. So we got IP addresses. We definitely have IP addresses, but it's saying the 10.20.20.2. Now this could be a class full IP address, so the network could actually be 10. Okay, so let's not get hung up on that. The network can actually be 10, and the host bits could be the remaining. So the host biddies, the host biddies could be actually these right here. All right, the host biddies could be these right here, and the 10 can actually be the network. So they could possibly be in the same network, okay? Because we don't have the opportunity to look at any subnet information or anything like that. So we just have to assume, we're assuming that the 10 is the network, okay? But what we're seeing is the actual, oh, I lost my thingy. It's fine, okay. We're seeing that the status is actually down. My server went down. It's okay. I can get my server back afterwards. All right. Disconnect the cable. Yeah, let's go with disconnected cable. All right. So that's good. All right. Refer to the diagram. If auto negotiation and speed and if auto negotiation of the speed and duplex between host A and the switch failed, so the switch in the host, okay, what should be the resulting speed, assuming sense failure in duplex, okay? So when auto negotiation fails between a host, assuming sense failure, it's always going to be going for the lowest duplex and the lowest speed. So we're going to be looking at 10 and a half, okay? Because the lowest speed on host A is 10. Okay, the lowest speed on the switch's interface is 10. So we're going to be going 10 and a half. All right. All right. Refer to the exhibit based on the information shown in the exhibit. What can be said of the configuration on gigabit on what can be the configuration of gigabit 0-4's interface? Select two answers. Gigabit 0-4. All right, so it's been manually set to half in 100. Okay. Interface speed, auto negotiate, no. Speed, no. So it's been manually set to duplex half and speed 100. All right. Refer to the diagram. Assuming auto negotiation is enabled, what would be the resulting speed in duplex between the switch and host B? Okay, the switch and host B. Okay, host B is fastest. Now auto negotiation is enabled and it hasn't failed, so it's working. Okay, so we're going to be looking at 100 in full. 100 in full. Okay. What are common local area network layer 1 problem indicators? Okay, layer 1. Okay, not layer 2, not layer 3, not a layer anything else. Layer 1. All right. So we have collisions and we have late collisions. Okay. All right. Remember, layer 1 doesn't care about anything layer 2, layer 3, anything like that. Layer 1 is that's where you have your collisions. Okay. All right. Refer to the diagram. If auto negotiation of a speed in duplex between host B and the switch works, what would be the resulting speed in duplex? So if auto negotiating speed between host B and the switch works, so the auto negotiation is working between host A and the host B and the switch, what would be the resulting speed? So we have 100 in full. 100 in full. All right. What Cisco iOS command can be used to display which VLANs are supported over a specific configured switch trunk? Which Cisco iOS command can be used to display which VLANs are supported over a specific? So we're going to be looking for show interface trunk. So show interface trunk. Select it. The show interface trunk will show us the information of what pretty much like what trunks, what interfaces are being covered by this trunk that I have, pretty much. Based on the figure, what Cisco iOS command would be used on a switch SW4s to correctly configure a switch port 501 to be able to access port in VLAN 30. Let me read that one more time. Based on the figure, what Cisco iOS command would be used on a switch 4 to correctly configure the 5. So all right, that's easy enough. So that's switch port access VLAN 30. Easy enough. Refer to the exhibit in the diagram to make it possible for all traffic to pass between PC1's local area network and PC2's local area network. The link between switch 1 and switch 2 will be configured as a trunk. Which Cisco iOS command could be used on switches gigabit 0-1, this interface right here, to force it to actively attempt. Now we want it to actively attempt to become a trunk with switch 2. All right. So what do we got? So we got switch port trunk auto. We got switch port mode dynamic auto. We got switch port trunk negotiate, and then we have switch port dynamic desirable. So what's that pretty much saying is, if the other, now remember, the by default on Cisco switches, they are set to auto by default. Okay. If we were to configure on the switch 1 here on the gigabit interface that's obviously connected to the switch 2's gigabit interface, if we were to enable the dynamic desirable on switch 1, what's that going to say is, when those messages are coming back and forth, it'll be like, okay, if you don't want to become a trunk, that's fine. I will become a trunk, because remember, auto, it won't become a trunk at all. All right. In this network, all switches are powered on, and all relevant VLANs have been configured correctly and are working based on the output in the exhibit. Which of the following statements are true? Which are true about switch 2? Switch 2. Oh boy. All right, we got that is super small. I can barely read that. So much information. So we have one VLAN, 24 fast Ethernet interfaces, 2 gigabit Ethernet interfaces. Show VLAN brief. All right, look at that right there, guys. So we have fast Ethernet 20, 21, but we're not seeing 22, 23, and 24. So what's that telling us, guys? That's telling us we might have a couple of trunks on this switch here. We might have a couple of trunks on this switch here. We should pretty much, because remember the trunks, when you look at the VLAN brief, your trunks are not actually going to show up. So there are 3 trunk interfaces. Not enough information is provided. 2 interfaces of the trunk. No, because remember we had 22, 23, and 24 not showing up on that show VLAN brief there. All right. So we had 3 trunk interfaces. All right. What is true about the command switchboard non-negotiate? What is true about the switchboard non-negotiate? If it's connected to a switch that uses dynamic desirable, the neighboring switch will not trunk. That sounds pretty good. This causes TCP message packets to be sent. No. This is used on a router to prevent VLAN hopping. Nope. This is on by default. No, it's not. The command is used to prevent switchboard from trunk. No. So, if connected to a switch that uses, remember, dynamic desirable, the neighboring switch will not trunk. Okay? Because that will pretty much say, let me get my telescope, right? It was even hard for me to read that last code excerpt. I can imagine what it looked like for you guys. I need to wear my reading glasses next time. All right. RSTP serves as a rapid spanning tree protocol, serves as an improved protocol in comparison to the older STP. Which of the following answers list a feature of RSTP that does not exist in STP? All right. Which feature of RSTP does not exist in STP? Woo! It's going to be a fun one. All right. The criteria used by non-root switches to become its own. The criteria used by switches to determine the ports active with backup role. That sound, yep. Because remember, in STP doesn't do anything about backup roles or anything like that. The criteria used to switch to determine designated ports on a segment. The criteria used is to determine a port to act as a backup role. There we go. Gonna go with that. All right. Ooh, we're getting into STP questions. These are the fun ones. We're 61 questions in, guys. Woo! Let me see. Yeah, we're not even halfway there yet. We're not even halfway there yet. I knew this was going to be a long one. All right. The exhibit shows a diagram of a small switch network. All switches use layer 3 switching and no layer 3 switching. Okay, so everything's using layer 2 logic, not layer 3. The diagram identifies the root switch as switch 1. So we got Mr. Root right here. All root ports, all right, and designated ports for VLAN 10. All switches have the spanning tree mode RSTP, PBST, rapid PBST command. All right. The answer lists the ports. The answers list ports that are neither root ports nor designated ports. Choose the answer that that lists an RSTP port role that is meaningful for the port topology here. All right. So we got to think about. So this is what from alternate to backup. Alternate to backup. Alternate goes to root. Backup goes to host. Alternate goes to root. Backup goes to host. Okay, that's just how I remember it. All right. Switch 4's gigabit 0-1 could be RSTP alternate. So gigabit 0-1 could be alternate. Yes. Because it goes to root. Let's just circle that one. Switch 4's could be used as a RST backup. So we got to select 3 answers, guys. Can be used as a backup port. Maybe. Switch 3's 504 can be used as a backup. Man. Switch 504 can be used as an alternate. Oh boy. So this one, it's stating that can it be used as a backup or can it be used as an alternate? Now it's going to a hub. Now hubs, I know how much you guys love hubs out there. All right. Switch 2's gigabit can be RST backup port. Gigabit 0-2. No, because that would be going back to root. So we'll select this one. The problem with switch 3's 504 is it could pass through. It could pass through the hub to S4 to then gigabit 0-1 over here as an alternate. And then 502 could be a backup. All right, let's go with those 3 right there, guys. All right, we're good. That was a tough one, but we're good on that one. All right. What is the name of the new RSTP port state that replaces STP disabled or blocking state? All right. So what RSTP port state replaces the STP disabling or block state? Okay. So we have disregarding. Which of the following are functions provided by spanning tree protocol? All right. We got to select 3 answers. Which other functions provided by spanning tree protocol? Okay. Places prevents multiple copies of a single frame from being forwarded. Yep. Prevents broadcast storms. Yes, it does. Prevents max stable instability. Yes. All right. So we'll select those 3 right there. An STP topology with 3 switches has 1 link between each pair of switches. Which answer best describe the primary decision point as to which non-root switch has a designated port on that link between the switches and which does not. The device with the lowest bridge ID always becomes designated and the other switch becomes blocked. The switch with the lowest root cost become designated and the other ones will block. That sounds pretty convincing. highest bid, lowest priority. So the switch with the lowest root cost will become designated, and all of the switches will be blocking. All right. Assuming all default STP settings, which of switch 3's ports will become root port, and what will be the cost? So what do we got? Where is root? So switch 4 is root. So switch 4 is root. All right, switch 4 is root. So switch 3, what ports will become root ports and what will be the cost? So we have 50/2 and we got gigabit 0-1. Now which ones will be root? So fast Ethernet has a cost of 19. Gigabit Ethernet has a cost of 4. Okay. Now, if we were to say go from switch 3 to switch 4 via the fast Ethernet, we would have a cost of 19. Now, if we were to go gigabit Ethernet 0-1 to switch 1 down switch 1's gigabit Ethernet 0-3, that would give us another cost of 4. All right. So 4 and 4, obviously it makes 8. Which is giving us a lower cost of going via the fast Ethernet. All right. So even though the fast Ethernet is directly, you would assume it's directly connected to switch 4, which is root. The root port would actually be the gigabit 0-1 here. So this would be root port. All right. And giving the rest of the topology, this would actually be in the block phase. Okay. Because it looks like we got gigabit Ethernet going to the rest of the other ones. So we have gigabit Ethernet 0-1 with a cost of 8. All right, let's continue. In the figure, in VLAN 1, all switches have the default STP settings, and all trunks are up and running at 100 megabytes per second. Which statements are true regarding the behavior of STP in this network? For VLAN 1, after STP has stabilized, topology has stabilized. Okay. So switch 1 is root. Switch 1 is root. All right. Now we're going to select 2 answers. Which of the statements are true regarding the STP topology? Switch 1 will create hello messages regularly based on the hello timer. Yes, it will, because it's root. Switch 2, nope. Switch 2 is not root. Switch 4, SPA 0, internet will become a designated port. SPA 01. No. That'd actually be root. A root port. That'd actually be a root port. Switch 3's SPA 0 interface will be in the forwarding state. Yes, it will. All right, so let's go with those 2 answers right there, guys. All right. All right. Refer to the exhibit. Which statements are true about the input shown? We're gonna select 3 answers. Oh, we got a whole bunch to select from. Oh, this is talking about port channels now. All right. You gotta think about this. So we're using LACP protocol, LACP. So right there, we got one thing. Port security disabled. Passive and active. So we gotta select 3 answers. This is operational though. The remote interface connected to switch gigabit 0-1 must be configured to passive. The remote interface connected to switch gigabit must be connected, must be active. The dynamic Ethernet protocol is LACP. Yes, it is. It is actually operational. It's not using patch. Okay. So, passive or active? I'm going to go with active, guys. Let's go with active. All right, we were good. All right. Which spanning tree modes are IEEE standards? So we have RSTP, STP, and MS. So the multiple spanning tree protocol, and rapid spanning tree protocol. PBST plus and RPBST plus. These are both Cisco proprietary. All right. When you are configuring Ethernet channels between 2 switches, what are the 2 channel group modes that can be configured in one and using port aggregate protocol? So port aggregate protocol is desirable and auto. All right. LACP is passive and active. All right. Port aggregate protocol is desirable and auto. I believe. I hope. Yep, I was right. Auto and desirable. Yep, you got it, Par. You got it. That's one thing that was confusing me for a little bit. We're trying to remember those 2 between LSCP and PAGP. It got me for a little while. So when configuring interfaces to be part of the same Ethernet channel, which of the following should you configure identically? When configuring interfaces to be part of the same Ethernet channel, which of the following should you configure identically? Okay, so we need to select 4 answers. So we need duplex. We need the speed to be the same. All right. MAC addresses. All right. We don't care about MAC addresses. So they all have to be either access ports or they all have to be trunks. All right, we can't mix access ports and trunks in a Ethernet channel. Either they're all access ports or they're all trunks, one or the other. All right. What is the default bridge priority? Oh, I love this question. This took me so long to remember. So long. So 32.768 is the default priority of a Cisco bridge priority. Right? This took me forever to remember. It is just like up recently that I've actually been able to remember this. So 32.768 is the default Cisco priority. The exhibit list output from a switch. Which 2 statements are true? The exhibit list the outputs from a switch. Which statements are true? And we got 2. Looks like we got 2 answers to select from. Okay. Well, what do we got? So I'm already seeing one thing right here. It has a lower priority from the default. Okay, this is saying that the priority was set. Okay, to 24.606. Okay, so that's a little bit different. So that's one thing that sticks out already. It's in VLAN 30. All right. What else? So it looks like this is the root for VLAN 30. All right. All its interfaces are in the forwarding state. They look like, yeah, they're all fast Ethernet because they all have a cost of 19. All right. So what do we got? The bridge priority is lower than the default value of spanning tree. Yes, it is. All designated ports are in the forwarding state. Yep. There are 30 VLANs on the switch. I have no idea if there's 30 VLANs on the switch. There could be 2 VLANs on the switch. Just one is named VLAN 30. The switch is the root port for all VLANs on the switch. I have no idea if it's the VLAN. It's the root bridge for all the VLANs. It's not showing me all that. So we're going to go with those two. Two switches are connected by 4 fast Ethernet trunks. 4 VLANs exist. So we have 2 switches are connected to 4 fast Ethernet trunks. 4 VLANs exist. With members in each VLAN on each of the 2 switches, the network engineer would like to have the switches treat all 4 trunks as a single 400 megabytes per second trunk, with some traffic being forwarded over each of the links between the switches. Which of the following statements are true about such a configuration? Select 2 answers. The 4 trunks can be placed into the same Ethernet channel to achieve this goal. Yes, it can. They're all trunks. All right. The show spanning tree command lists the combined 4 links for the abbreviation of PO. Yes, it does. It doesn't abbreviate as EC. The spanning tree protocol uses would cause the balancing over 3 of the 4. No. So we're going to select these 2 right here. All right. All right. For which reason was RFC 19 address space defined? For which reason was the RFC 1918 address space defined? To avoid the delay of IPv4 exhaustion. Yep. To support NAT protocol, to reduce the internet routing table size. Pretty much. All right, because this is RFC 1918. That is what covers the the private IPv4 address ranges. Okay, and yes, you'll be using such protocols as NAT on the router's outgoing interfaces. All right. But it does not support the NAT protocol. How's that? So it's to reduce the internet's routing table size. All right. What 2 options are true about IP addressing rules? All right. So we got to select 2 options for IP addressing rules. Addresses in different subnets need to be separated by a router. Yeah, that sounds good. Addresses in the same subnet need to be separated. Addresses in the same subnet need to be separated by a router. No. Addresses in the same subnet do not need to be separated by a router. What does that say? Addresses in the same subnet do not need to be. All right, that's right. Addresses in different subnet. All right, so we're going to go with these 2 right here. Addresses in different subnets need to be separated by a router, and then addresses in the same subnet do not need to be separated by a router. Let's go with those 2. And we were right. The size of the subnet is calculated with the formula 2 raised to h, so h being the host minus 2, and that is for the subnet ID and broadcast ID, broadcast address. Right? Why are 2 hosts subtracted from this possible size? One host is to reserve for the default gateway address, and the other is reserved for the local broadcast address. One host is reserved for the subnet number, and the other is reserved for the subnet broadcast address. There we go. That's the one we're looking for. Nothing to do with DHCP, and yeah, okay. We're getting into subnetting. My brain's going to hurt. All right. If subnetting Class B network 172.18.0.0 using the subnet mask 225.225.240 for all subnets, which answers list an address in the second subnet. All right. All right. Let's crank this out real quick. All right. 225, 240.0. 256. Let's do 40. All right, we got 16. All right, so 172, 18, dot 0, dot 0. All right, so if we had an address range here, so we're going to be going 0, 16, 16 minus that is 15, obviously. All right, but we're going to keep going. So 30, 16 plus 16, 32. So it'd be 31. Then what do we got? We got 40, 48. So it'd be 40, 47. All right, and then the next two. So which answer lists the address in the second subnet? The second subnet. So what do we got? 16.10. This would be the first subnet. So it's 31. Yeah. And then 16. Yeah. Because this is still the first subnet. This would be the third subnet. All right. Love subnet. Love subnet. Oh, makes your brain hurt every time. All right. If an engineer at the Acme Corporation was tasked with submitting design for the new branch location with the only information the engineer was given is shown here. Use 192.168.100.0. Plan for at least 12 subnets of the same size. Plan for each subnet to have at least 5 hosts per subnet. Which of the answers listed correct? Okay. Let's get the calculator. I gotta get my powers of 2 remembered, but it's what we use calculator for, right? All right. So what do we got? So 2. Let's go. Let's start with 2 to the 5th. So we need 12 subnets. Might be too big. Let's try 2 to the 4th. 2 to the 4th would work. Let's 2 to the 3rd. All right, so 2 to the 4th. So 2 to the 4th would work. 2 to the 3rd is 8, so that might be right for the next one. So what's 2 to the 2nd again? 4, right? So 2 to the 4th and 2 to the 3rd is our range. So 2 to the 4th and 2 to the 8th is our range here. All right. So what do we got? That wouldn't work. That would work. That would work. Whoa. That won't work because host is 2, so that's 2 less. All right, so subnet. So these two. So 2 to the 5th to 2 to the 3rd, that would work, and 2 to the 4th to 2 to the 4th would work. All right. An engineer at the Acme Corporation was tasked with submitting design for the new headquarters. The only information she was given is shown here. Use 172.20.0.0/16 address range. Plan for at least 400 subnets of the same size. Plan for at least 50 hosts per subnet. All right, calculator again. All right, so we're going a little bit big this time. So let's try 2 to the 8th. Not enough. 2 to the 9th. Perfect. So 2 to the 9th. So we're looking for 2 to the 9th. Nothing less than 2 to the 9th. All right, looking for 50 hosts now. So let's try 2 to the 5th. 32, not enough. 2 to the 6th, probably the answer. All right, 2 to the 6th. So we have 2 to the 9th and 2 to the 6th. All right, that we're looking for. All right, first one won't work. The second one won't work. We need 2, so 2 to the 10th and 2 to the 6th, that'll work. And then 2 to the 9th and 2 to the 7th, that'll work. All right. Good. Which of the following addresses could be used as a private IP address? So private address. Which of the following could be used as a private address? Nope, not that one. That's a loopback. That could be used. Nope. And then yes. Okay. All right. How many unusable hosts are there per subnet? How many usable hosts are there in a subnet if you had the address 192.168.0.8 with subnet mask 222? All right. Let's do some subnetting math real quick, yeah? 225.240. So 256 minus 240 is obviously 16. So we're going to be going up by 16 here. So what is our address? 192.168.8.0. So that's our subnet ID. All right. So what do we got? We got 0, 16 minus 15. So we have an actual range of 192.168.8.15. That's our subnet broadcast address, okay? So if we had these two right here, all right, so how many ranges we got? We got 192.168.8.1 to 192.168.8.14, okay? So we got 1, 2, 3, 4, 5, 6, all the way to 14 addresses. 14 addresses, okay? All right. Which of the following is true about the classful address 128.44.2.2? Which of the following is true about the classful, all right? Class list, classful address 128.44.2.2. All right, so the classful, that falls into the range of, oh, my back, 2, that's a class B. So if that's a class B, that looks like the subnet ID. The first valid host, nope. The network broadcast address, nope. It's a class A. All right, so the network ID would be 128.4.4.0.0. Which portion of the 192.0.0.0 address which portion of the 192.0.0.0 address is in its network portion? Okay, so it's not specifying anything, so either way we have to just think about it as class full addressing, okay? And then the 192 is a class C. All right, so class C, so it's got 3 octets in its network portion. 3 octets, okay? All right. What are the default masks for each network class? All right. What are the default masks for each network class? So class A, that looks right. That looks right, and that's wrong. That looks right. That's wrong. That's wrong. That looks right. That looks right, and that one looks right. Okay, so it's the last one. What options correctly list the address covered by the indicating address class? What options correctly list the addresses covered by the indicating address class? So we have to select 2. Class C addresses begin with 192.223 exclusively. That sounds pretty good. That one's nope. Class B 128.2 exclusively. Yep. There we go. All right. Which of the following IP addresses / MAC combinations, if configured on a working router interface, would create a connected route for an entire classful network inside of a route for a subnet of a classful network? Woo! That's a big one to swallow. Okay. Which of the following IP / MAC combinations, if configured on a working interface, would create a connection route for an entire classful network? All right. Nope. Nope. 192.168.1.24. Yeah, that sounds good. Nope. Nope. And then 172.16.1.1/16. And what that's pretty much stating is because, so again, if we're thinking class full, all right, so we're thinking class full, 192, obviously class B, first three octets, giving us a subnet mask of /24. Obviously, would cover these three network octets. Okay, so that would cover an whole entire class full address range, and the same thing with the 172.16. So the 172.16 giving us a subnet mask of 16 again as well. Thinking class full addressing again, this would cover this entire network range as well, too, guys. So that's why I'm gonna select those two. Let me see what happens. Boom, baby, we were right. All right. I need more something to drink. What is the Class A network ID of the host shown on the single local area network figure? Oh, my back is killing me. Okay. What is the Class A network ID? Class A network ID. That's 10, right? Yeah. So if we're thinking classful addressing, is all in the Class A network range. All right. Everything else is host biddies. All right. So it'd be 10.0.0.0. We're good. All right. Given a mass 225.225.225.0, which of the following statements are true? All right. If a Class B network had this mass, up to 245 possible subnets could be created. There could be 245 possible hosts on the subnet with this mask. This is not a default mask for a Class A address. That sounds about right. And this is a default address for a. This is a default address for a Class C. Okay. There can be 245 hosts on a subnet with this mask. Sounds about right. Class B network had this mask. If a Class B network had this mask, up to 245 hosts, subnets could be created. We'll go with that one. Let's go with that one. Yep. All right. We were good. All right. If subnetting the network 192.224.10.0 with the mask 29 for all subnets, what is the subnet broadcast address for the fifth subnet? Woo! Subnetting. We love subnetting. All right. Let's work this out, guys. Let's work it out. All right, 29. That's 248. 248. And then, what is our address range? 192. 224.10.0. Okay. 256 minus 248. All right. So what do we got? We got 8. Yep, so we got 8, so we're looking for the fifth subnet range, okay? We can go 8, obviously this would be 7, 16, 15, and 8 again. 8 plus 16 is obviously, that's 24, so that'd be 23, then 32, 31, then 40, so giving us 39. So what we got? 1, 2, 3, 4, 5, so 39. 39. So on the fifth one, it'd be 39. All right, we're good. All right. Given a prefix length of /29, what is the correct dotted decimal number? So it'd be 225, 225.248. All right, the figure shows an internet network with IP addresses and default gateways for some devices. The addresses have been configured on the router, and the PCs have been configured using the same subnet mask as the router on the local area networks. A router protocol has been enabled on both routers, and both routers have learned all routes known by the other routers. Which of the following statements are true about the behavior in the IP network? All right. So what do we got here? A new PC added to R1. A new PC added to R1's local area network can be assigned the 10.4.5.255. No. Oh wait, it might be able to. With 2 IP addresses assigned, a new PC in R1 can be assigned the. Hold on, I gotta figure out the information for one subnet area. So let's go with the subnet area off of R1's interface. All right, that's the 10.4.4.200/23, and this 23 gives us a 255.255.245 subnet mask. So 255, 255, 254. Okay, about 0. That's 10.4.4.200. All right. Obviously, that's going up in increments of 2. So we have 2, 2, 4. Okay. So, and then 6. So 5. So the subnet broadcast address is actually 10.4, 10.4.5.255. Okay. All right. So we can actually have an IP address of 10.4.4.254, and that would actually be a valid IP address. This would actually be a valid IP address. All right. How many answers? We're just the one. So we're just going to go with that one, since that one, we identified that one as being right. All right. Even though it was the 10.4.4.255, even though that looked like a broadcast address, the actual broadcast address for that subnet ID was 10.4.5.255. So that 10.4.4.255 is an actual valid IP address in that subnet range, in that IP range there. Customer support rep at the help desk is working a problem. The problem record mentions an address 172.16.1.1 and the mask of 254.255. At lunch, a lunch and learn session yesterday, the rep heard the network engineers team say that they avoided variable length subnet masks by using only one single subnet mask in the network 172.16.0.0. Which of the following answers is accurate regarding the implementation of the 172.16 in its subnet plan. So what's up, Matt? Big time review, huh? When do you take the real exam? I'm hoping to take the real exam in February. That's what I'm hoping for. With everything going on right now, I should be complete with all my reviewing by about mid-February. In about a week or so, I'm actually going to be. In about a week or so, I'll be actually signing up for the actual exam. So hopefully I can get a date sometime in February. I want to make it by February just because I still want, because I'm going to register for both the CCNA and the DevNet one at the same time. Because I want to be able to the big hype. I want to be still part of the DevNet 2020 crew. And I have till about February to register for that, to still be part of that DevNet 2020 crew. So I'm going to be registering for both the CCNA and the DevNet. Again, hopefully by next week or so, depending on how everything's going. I'm about financially, with everything, with the stimulus and everything, I should be able to afford both of those exams now, because I wasn't able to afford it before, but now I can afford it now. So hopefully about mid-February I can be able to do it. Do you really? Schedule mine for the 29th. That's awesome, dude. Dude, I am so pumped. How are you feeling about it? Like, where are you, like, are you comfortable about where you're at with everything? You know what I'm saying? How you feeling about it? I would love to hear back from where you're kind of at with your studies. Are you still studying? Have you been doing some labbing and stuff still? I know. I don't know if Maradoxbat is in here. Maradoxbat is actually be taking his. His is on the 19th. I believe that's the beginning of next week. Feeling pretty good, honestly. Been taking Bosun NetSim in random orders, trying to get to the point where I'm not missed a single question. Getting pretty fair with the questions, but that's the idea. Heck yeah, dude. That's what I'm doing today in the Pearson stuff too, man. I'm just, as you can tell, we're doing 155 questions from all the way from chapter 1 all the way to where we're in chapter 21 right now, which is the end of OSPF. So we just covered OSPF. We're about to be entering into IPv6, which is the next part of the studies. But we've covered everything all the way up to the very end of OSPF, and that's what we're going to be reviewing. Well, we're covering everything up until OSPF right now. So, all right. So we need to know the subnetting plan on what they were thinking about here. All right. So 255, 254.0. And the subnet 172.16.1.1. Okay. So obviously they're going to be going up. They're going to be going up in increments of 2. So if that was the case, then, so we have 0. Obviously we got 2. And then that is that. So that'll be 1. So we have 172.16.1.0 as the subnet ID, and then 172.16.1.254 to 255 as the subnet broadcast. No. Wait. I'm doing this backwards. No, I'm not doing it backwards. No, that's right. Right. Oh, wait, no, it's 0. It's 0. Yeah, it's 0. So it has So if that was 0, so definitely stick around for IPv6 then. Remember, different multicast, unicast, global versus local stuff has been my latest struggle. Oh, all right. Yeah. Yeah, I can't, like, I've been dreading IPv6, man. I've been dreading. Like, I understand the concept of IPv6, but I really haven't spent too much time diving into IPv6, so it's going to be interesting. All right. So what do we got with this this type of a mask here? So we have, so if we did the math, this can go all the way up, obviously, to 0 to 255. So we have 172.16.0.255. All right, minusing that one address, and they keep going to 172.16.1.254. All right, that gives us, it gives us a big address range, actually. Big address range. Let's get the calculator out. So we had 255 plus 254. It gives us the network supports 256 subnets. It would support because it right here. It would support about 510. Six. Let's go with those two and see what happens. The network supports up to 128 subnets. Let's read why. All right. Define mask. Yep. It's 23, 16. Oh, I get what it's saying. I get what it's saying. Because 2 to the 7th is 128. I get what that's saying. Okay. All right, I get what that's saying, because what it's implying, and I apologize for that, is because obviously here, what it's implying is we have 9. So there's 9, 1, 2, 3, 4, 5, 6, 7, 8, 8, and then 1 plus 1. So there's 9 host bits. So 2 to the 9 gives us 510. All right. 2 to the 9th, that gives us 510. And then assuming And then assuming because of this right here, obviously on a class C, because obviously 172.16 is a class B, class B network. Assuming that this was all network, what it's assuming is the rest of these host biddies, which there is these bits right here, the 254, which gives us 1, 2, 3, 4, 5, 6, 7. I get it now. All right, giving us 7 in this 254 range, okay, which that would be 2 to the 7th, which is 128. So that's where I got that wrong. Yeah. I understand now, and that's where I messed up. That's where I messed up. These types of questions get me every single time. These crazy subnetting questions messed me up. So yeah, so again, to get back to the logic of how it's asking me, is the 172.16 is a class B, dictating that the two first octets fall into that range, but this octet right here with the seven bits that are in this 254 range right here, all right, because if you to do 7 bits each equals 254. I get it. Okay. All right. I get it. I get where that was going. All right. All right. How many? One thing with Boson Sim, I had a bunch of extra time, so I feel free. So feel free to take a little extra time and count. Yeah. Yep. Yeah, I don't have the timer set up on this one yet. I could have done the timer. I should have done that actually. I should have set up the timer on it just to give it like a real life I guess example of trying to get through these questions like if we would when we're taking the actual exam. All right. How many bits are used for subnetting? Yeah, that's what I'm using right now as a simulation. I guess in Boson might be simulation mode. This is the study, quote unquote. It's probably the same thing in Boson, but in the Pearson it's called study mode. So it's probably the same thing where it'll tell you when you get it wrong, and then it'll give you the explanation. Same thing. Apples to apples almost. How many bits are used for subnetting a subnet based on the sample address 125, 168, 32, 99, 255, 255.128. How many bits are used for subnetting a subnet based on? Okay, so 125. That's a class A. That's a class A network, guys. So we have, and then a 128. 128 let me see, there's 9. So 8 plus 9. We have 8 plus 9. How many bits are used to subnetting based on the sample address? What are you asking me, man? Your class A address. And I don't see 17 on there. I'm going to go with 9 with the 128 because honestly, I don't know why. How many bits are used for subnetting in a subnet based on the sample address? I would say 17. That would be my answer, but I don't see 17 on there. The reason why I'm saying 17 is the 125. So 125 falls into the range of class A. All right. So if we're thinking class full, it would be the 255. All right. And then everything after that would be subnetting, would be the subnetted portion. If I'm thinking about that right. All right. So that would give us 8. Hold on. I'm thinking about this wrong. So it's 9. Oh, it's 9. My head hurts. I am thinking about that right. It is 9. It's 9. It's 9 bits. Because, see, now I'm stumping over myself now. Yeah, it's 9. Meridoc spell. 12. Hold on. I believe it's 9 because, so 255. 255, 128.0.0. So we have 1, 2, 3, 4, 5, 6, 7, 8, and then 9. That would give us the 128. So it is 9. Because, yeah, right? If I'm right, it'd be 9. So I was thinking about that correctly. So it is 9. See if we're right. All right, we're good. That one stumped me for a second. My brain, I must have had a quick seizure or something like that, or an epileptic moment. All right. We're looking at the address using classless. Now, classless addressing rules. How do you know the length of the prefix? When looking at the address using classless addressing rules, how do you know the length of the prefix? By looking at the amount of bits that are binary 1 in the mask. It sounds pretty good. By looking at the first 3 octets, we don't know. By looking at the number of host bits, by looking at the first 2 octets, by looking at the amount of bits that are binary 1s in the mask. I'm gonna go with that one. When looking at addresses using classless addressing rules, how do you know the length of the prefix? By looking at the mask, by looking at the amount of binary bits, binary 1s in the mask. All right, we're pretty good on that one. Yeah, that's what I thought too. All right. What is the prefix notation of 25.252? I believe it's 25/25. Yeah. Ah, dumb Joe. Dumb. Going too fast. Going too fast. Let me write my little handy schmandy thingy on the board here. What do we got? So we were going binary bitties. 8 binary bits. So we have 0, 2, 4, 8. Try to remember that 0, 4, 2, 8, 16, 32. That's gonna be not gonna be long enough. Then we start over here. 0, 2, 4, 8, 16, 32, 64, 64, 90, 64, 128. Yeah, there we go. That's where I messed up. I know I messed up. All right. An engineer first confirms data routers interface 500 is up and working. He then, and the reason why I wrote that is so if we have a subnet mask, obviously, to discover it, you obviously like 128 plus 64. That gives you 128 plus 64. Gives us 192 plus 32 would be 224 plus 16, 240 plus 8 gives us 248 plus 4 would have given us 252. So it was plus 4. So we had 1, 2, 3, 4, 5, 6, 7, 8, which is the 255, and then 1, 2, 3, 4, 5, 6, 7, 8, which is the 255, and that other one, and then obviously the 252. So that it gives us 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. So 8 plus 6. This is where I should have done. I just should have done it on the board to make it better. So 16 plus 6 gives us 16 plus 6 gives us the obviously 22. I should have done that on the board, because that would have helped me instead of just guessing at it. But that's how you would find so writing the 128, 64, 32, 16, 8, 4, 2, and then 0. This is obviously this gives you a quick rule of thumb. And then, like LMath was saying, you're going from, instead of going from left to right, you go right. You go left. Well, instead of going right to left, you go left to right. So you would just put the subnet mask counting from 128, 64, 32, 16, 8, and then so on and so forth. And then you would just count the binary bits. So you add these all up, giving you whatever dotted decimal notation that was given you, and then you just count the binary bits it took you to get to there, and then you add it up, and then you get the slash notation from there. Yeah. Yeah. Yeah, I'm a dum-dum sometimes. Dum-dum. All right. An engineer first confirms that a router's interface 500 is up and working. He then confirms that the interface with an IP address 10.101.101.101 with the subnet mask 255.255.128 command. The engineer leaves the configuration mode and issues the show IP route command. Which of the following masks will appear listed in the output describe the connected route that exists as in a result of the IP address 128. So again, if we to do this, again, to get back to that, so we have 255.255.20. So 255.255.255, that's 24. So that would be 24. So 225, and then what is it? 128. So that'd be another 8. 1, 2, 3, 4, 5, 6, 7, 8. Now again, if we're looking for 128, that's only one binary bit. All right. So we got 8, and then 8 right there. Clear that. All right. This is again what I should have done last time, but I should have just done it on the board. All right. Plus 1. All right. So 8 plus 8, 16, plus another 8, 24, plus 1, obviously giving us 25 right there. All right. So it'd be 25. All right. The figure shows an internetwork with IP addresses and default gateways on some devices. The addresses have been configured on the router and the PCs have no configured. PCs have been configured using the same subnet mask as the router on the local area network. A router protocol has been enabled on router has been enabled, and both routers have learned all IP routes known by each other. Which of the following statements are true? Also, the pre-unit online tests, no pen and paper. Get used to writing with a mouse on a whiteboard. Paint for anyone else watching. Oh, okay. Also on the online test, no pen or paper. Get used to writing with a mouse. Whiteboard paint. Oh, is that how it's so? So is that how it's done on that's how it's done on the actual online exam there, LMath? Yeah, all right. So you do it with all right. Everybody should take the real CCNA on the real CCNA exam. So take note of that, everybody. That you're going to be using the Paint program. I guess that, yeah. I don't know if that's a good or a bad thing. At least they give you the ability, I guess, to use something to write on. But yeah. Is it the actual, like, the Microsoft Paint program? Is that what it is? All right. In the figure. All right. So we're looking for two answers. Yeah, at least we get something. It's a whiteboard. All right. It's something at least, I guess. Because what is it on like the physical one? They give you like scrap paper or something like that, right? But that whole thing, that 128.64. If I pass the CCNA, I hope I don't do any networking certs again. Come on, Maradoxbat. We gotta go CCNP. Then we gotta go CCIE. Come on, we got so many certs we gotta go through. We got DevNet we gotta do next, Maradoxbat. We can't give up on just CCNA. This is just the start of our networking career, my friend. Our brains are gonna be like just pouring out of our ears, but it's all for the good cause. Quadruple CCIE. They exist. They're out there. Those guys are maniacs, but they exist. I want to say Kevin Wallace. I want to say Kevin Wallace and who's that other guy? Kevin Wallace. Is Anthony Santoro? Is Anthony Santoro quadruple CCIE? I believe Kevin Wallace is. That guy is a genius. Kevin Wallace. He's like a mathematical genius. That guy. And it's funny, like he's like someone like you wouldn't expect to be like a mathematical genius, but he is. Anthony Squire, yeah. Is he a quadruple CCIE as well? He does that the IT Pro Network. I might do some CCNP security. You better do some CCNP security, Maradoxbat. You better go CCIE all the way. All right. So we got to select two answers here. What do we got? PC3 should not be able to beat ping PC1. PC3 is in a different subnet as router LAN. All right, let's figure out the subnet range for R3 real quick on its on the interface going to PC. So what do we got? We got 128. So 128. Let me just 128 is 240. So we got 2 for 5, 2 for 5, 2 for 5. 240. All right, 256, 240. All right, 16. What's our address range? 192, 68, 200, 1. So 0, 16, 15. It's in the same range. What's the other one though? Ooh, we might have an issue with the R1s. Our PC1 might actually not be in the same subnet as R1. What do we got? We got 127. So 224. So 225, 225, 225, 224, 256. That's 224. We got 2. So we got 32. So 0, 32. 32, 64. 32 plus 64. We got 90. 96, 5, yeah, all right. So PC1 is actually not in the same subnet as router R1. PC1 should not be able to ping PC1, that's true. PC1 is in a different subnet, yes, all right. All right, so it's those two answers right there. All right. Which IP address could be used for host in subnet 151.192.8.48? Which subnet could be used for a host in subnet? Let's just figure out this real quick, guys. So 29 gives me 248. 8, 6, 48. Obviously, it gives me 16, 8. So 0. What's our IP address? 151. 2, 8, 48, 8. 16, 32, 32. That's not 32. 16. 24, 32, 40, 48, 56, so 55, so 1951, 192, 8, 55. So we got to select 2, so this first one could be a usable host. And the second one. Nope, nope, and nope. Okay, we're good. All right. The figure shows addressing for all devices in a small lab network. PC1 can ping PC3. Which of the following statements accurately describe the allowed space for IP growth in this design? What do we got? PC1 can ping PC3. Which of the following statements are accurately described about the allowable space for IP growth? Select 2 answers. The subnets that are used on the serial link can allow 4 addresses, but they are wasted because no other IP addresses. An additional 4? No. They only allow 4 addresses, actually. Not 4 additional addresses. So we can cross that out. R1's local area supports 300 hosts. We'll have to take a look. 2 addresses assigned. All right, let's just figure this out real quick, guys. All right. 23, so that's 255, 255, 254, 0. And our address range is 10, 4, 4, 200, whatever, 2. So obviously 0, 2, 4, and then 6 there, so 5. All right. 10.4, 5, 255, and then 10.4, 4.0. So that gives us that gives us a shit ton of addresses right there. So that gives us, yeah, that gives us a lot of address ranges in that one. And then on the other, side, so we have 255, 255, 255. We got 1, 2, 3, 4. So that gives us 4, which is 240, 240, 16, 0, 16. And that is 172, 225. Yeah, so let's just figure that out. With 2 IP access assigned, 3 subnet allows for 12 additional, because it gives us 14. Yeah, 2. The /28 gives us 14 addresses. Minus 2 gives us 12 additional addresses. Yeah. All right, we're good. All right, cooking gasoline again. We're back on track, guys. To which subnet does host 192.168.148.76 belong to? Which subnet does /29 again is 240, right? No, 248, 248, 5. 248. All right, gives me 256 minus 248, 8. All right, 192.168, 148, 6. So that's 72. So 72, and then 80, so 79, right? So we got 192, 168, 148, 79. That's the broadcast, and then 192, 168, 148.72 is the subnet IP. Okay. So 172. Which of the following IP addresses could be assigned to a host? Which of the following IP addresses can be assigned to a host? This is a loop back. What is the broadcast address? What is the broadcast address for the subnet that hosts? What is the broadcast address that for 172.121.118.25 belongs to? Let's figure that out real quick. Five. 72. 2. So that would fall into that. So 118 would fall into that. Next one would be 20. So 18. So 172, 22, 119, 225. All right, the diagram shows a small network with three VLANs. The network engineer, the network engineer needs to assign IP addresses to the host to allow them to communicate with each other. Which two of the following addresses accurately describe the requirements for addresses in the small networks? The diagram shows a small network with 3 VLANs. The network engineer needs to assign IP addresses to the host to allow them to communicate with each other. Which 2 of the following answers accurately describe the requirements for the addresses in the small networks? All right. If PC1 is assigned an IP address 10.1.1.1, and PC address is, would that be in the same subnet? We'll take a look at that. You got to select 2 answers. PC1 address must be in the same subnet as PC. No. If PC address is 199.255, so that one's wrong. That one's right. So we can just select these 2 real quick. They're both right. All right. You don't even have to look at. You don't even have to do that whole crazy subnetting math to that question. All right. Which of the following IP addresses could be assigned to a host? Which of the following IP addresses can be assigned to a host? Nope. Looks like those 2 right there. All right. Refer to the diagram in the exhibit based on the information displayed. And I don't know why I know those ones. It's because of where they're falling in with classful IP addressing. Class-full IP addressing. That's the only reason why I'm guessing those ones. Just a heads up. Those ones are tough, and I don't know. I get like a feeling on those ones sometimes, and I say, okay, those ones. Usually I get them right. Based on the information displayed, what is the cause of the correct interface having a down protocol? So what do we got? We got a serial. So which serial was that? One serial on router 1. It's 1/0, and then router 2 it's 1-1/1. Okay. 1-0. It's got an IP address. The protocol is down. The status is up. The protocol is down. And then on 1-1, we got a similar thing. Again, we're going to assume that they're in the same network, going off of class full addressing. So the 10 would be the network, and then everything else would be host, manual, up, and the protocol is down. Okay. Ooh, let's look at that again, actually. So the clock is not configured on R1. No configured interface clock rate. Okay. So we have no configured interface clock rate on R1, causing the issues. Okay. You are troubleshooting connectivity issues with a router. You type in the command show IP interface brief. You notice that the status is administratively down and the protocol is down. What is the meaning? What is the meaning for the information? Show IP interface down. You notice that the status is administratively down. So the interface has been shut. The shutdown command has been put on it because it's saying administratively down. Okay. So somebody went in there and actually gave it that command to shut it down. The exhibit shows a output of the show IP interface brief command on router R1. All interfaces list in the exhibit showed work under normal conditions, and you have worked in the past. So it has worked in the past. Which of the following is the most likely condition that would cause the output of this show command in the exhibit? Holy guacamole, we got a lot of stuff to look at here. Up, protocol down, administratively shut down, down. Serial link is actually just down, up, down, administratively down. Serial link connected to servers having one telco. Don't know that. The router, one of the service interface has been configured with PPP. But R1 is still using this spelled HTLC. That could cause a problem right there. On serial 1, 1-1. Yes, so that could actually be the problem right there, and the reason why the protocol is stating down. 1/1 does not have any problems. That don't matter. So let's just go with the mismatch on the protocols. Okay, so that was the answer right there. All right, it was a mismatch on the point-to-point to HTLC. That mismatched configuration on the two routers was putting that protocol down. Of the Cisco iOS command that are typically used to view interface IP address information, which one shows only the address? Which one shows only the address but not the mask information on the interface? So that would be the show IP interface brief. The show IP interface brief. Protocols that'll actually show the actual subnet mask notation. So the show IP interface brief. Which command would you enter? To add an IP address on a router's interface? So it would be IP address and then the mask. So there's no mask command or anything like that. This would be invalid. And this, again, there's no subnetting command. So it would be IP address and then followed by the mask. Okay. Refer to the diagram. Which cable type is used in this reference? So we have a serial cable here denoted by obviously like the electric boat. So we're all familiar with the electric boat and what that denotes. That denotes a serial connection to a channel service unit and a data service unit. So on most modern day routers, like your home router, the channel service unit, data service unit is actually built inside of your router. On this reference, and it's referencing that it's a detached unit with a serial cable going to the channel service unit, data service unit to then your router. But this would still be a serial cable from the channel service unit, data service unit to your router. So it'd still be using a serial cable. All right, not a coaxial. That used to confuse me. I used to think it was a coaxial cable going in. It's not UTP. I thought it was. You could think it was a UTP, but these channel service unit, data service units, they're still using a serial cable to connect between each other. All right. Which type of router is commonly used to connect to an external modem so that an engineer can remotely access a device? So which type of router port is commonly used to connect to an external modem? Here we go. So an external modem so that an engineer can remotely access that device. Okay. So if we're an engineer and we want to connect to an external modem, we would be using like a phone line to connect to that external modem. All right. So we would be using the auxiliary port. Okay. All right. Refer to the diagram. Which static route statement on R1 would be configured to ensure that all normal traffic going to 30.30.30.0 network would be routed via the primary path. So we got the primary path to 30.30.0 right here. And all traffic going to server A to be routed on the high priority. You got it, Maradoxbat. You know it, baby. You know it. All right. So we got to select two answers. All right. So what did we get? Yeah. So this is wrong. I know that. So let's go with IP route 30.30.30 slash 255.255.255.0 via 220. All right, 20.20.20.2. All right, going the primary path, and then anything going to the server here, we're going to say IP route 30.30.30.100 via 255 over 10.10.10.2 here. All right, we'll go with those two. All right, we're good. All right. PC1 just powered on and has not set any frames into the network. PC1 has a statically configured IP address in default gateway. All right. Default gateway is configured as the router's FAR01 interface. PC1 is statically configured with the IP address. All right. PC1 sends a ping to 172.16.0.33. So PC3 over here. What dynamic ARP entry appears in the ARP cache of the various network devices? All right. So when PC1 sends that ARP, obviously he pings it, and then obviously it needs to, that ARP message is going to go before the ICMP echo. So what's going to happen is it's going to actually ARP the FAR01 interface on the router. All right. And the router then is going to send out its own ARP message out its FAR01 to PC3, and then PC3 is going to respond back to the FAR01's interface, and then that ARP cache, that ARP reply, all that information is actually going to be saved on the actual router here. All right, not on the individual PCs. All right, that's a security type thing. So the MAC address 0.111, so PC1's MAC address in the ARP table on that. So yes, so that cache is going to be actually kept on the actual router. All right. Refer to the exhibit in the figure. A branch office is going to be using Ethernet WAN links as a primary WAN link with a serial point-to-point link as a backup. The design uses OSPF over Ethernet WAN. What command enables you to configure a floating static route on the branch router to 200.200.200.200.0/24 network should be the primary if the primary link were to fail. Serial port point to point. The designer of OSPF over Ethernet WAN. What command enables you to configure a floating? So you got to remember. So OSPF has a default cost. So the default administrative distance cost of OSPF is 110. All right. A configured static route has an administrative distance of 1. A connected route has an administrative distance of 0. All right. So if we wanted to create a static route to this central site here, so we want to floating static routes to the branch router to 200.200. So we want a static route to the central site. We need to create something that has a greater administrative distance than OSPF. So anything that's over 110. So we have 2 here, but we got to figure out what link. So we want to go over that serial link. We want off of this serial link right here. That's what we want. So we're going to look for the address 150.150.150.1. So the 150.150.150.1. That would be our answer, okay? All right. In the internal network shows the diagram. R1 is the central site router. R2 is typically the remote office router. The network manager dictates that the remote router should use a default route to forward the packets back to the central site, while the central site router should use the static should use the static route to forward packets to a remote office local area network. As soon as the network manager has correctly implemented the design, you connect to R1 and R2 using Telnet and issue the show IP route command. Which of the following answers would list? So R1 to R2 typical dictates that the remote router should use a default route to forward the packet to the center site, while the central site should use a static route. So the remote, all right, so we have the remote site, and that should be using a default. So R2 would be using the all zeros via its outgoing interface. And then the R1 needs the static to forward to each. All right, so R1 needs to all right. We'll go with those two. All right. Looking pretty good, guys. We're looking pretty good. How far are we at right now? Ooh, we're at 116. We're about 3/4 of the way there, guys. We're actually doing pretty good on this exam. We got caught up on a couple of the subnetting questions. Man, I got to go back and really beat up subnetting some more. I'm telling you. Subnetting is one of those things, man, that'll just creep up and bite you on the butt. Host B issues a ping command to ping host D, IP address, the ping command. The ping command succeeds. Which of the following statements is true regarding the ICMP echo request sent by host B? We've got to select two answers. So host B to host D over here. So it looks like going to a router over some HDLC, over some yeah, okay. The frame holding the packet as across the cable between S3 and S1 has the MAC address of R2 as the source MAC address. Yeah, it would. I'll go with that one. Frame holding the packet as across the cable between switch 1 and switch 2 as the destination MAC. R1. That sounds pretty good. The frame holding it is across between cable between R2 and R1 has host B's MAC address as the source. The frame holding the packet as it crossed the cable between R2 and R3 has the source. The frame holding the packet as it crossed the cable between the frame holding the packet as it crossed the cable between switch 1 and switch 2. We'll go with these two right here. The frame holding the packet as it crossed the cable between switch 1. R1 has the destination MAC of frame as it crossed the packet. Frame holding the packet as it crossed the cable between switch 3 and the hub 1 has the MAC address on R2's source. Oh, wait. This one's wrong. It's this one. All right. Almost got confused for a second on that one, guys. All right. Refer to the exhibit in the diagram. Which static route statement could you add to the central router to ensure that the default route always exists in the routing table regardless of the interface statement? Refer to the exhibit and diagram. Which static route statement could you add to the central router to ensure that the default route always exists on the table regardless of the interface statement. Central route. So the IP, yeah, the IP route 0.0.0 to 0.0.0 to the 192.168.1.1 permanent. Which Cisco iOS command is used on a 2960 switch to change the switch forwarding A6 setting to make sure to make space for? So this one, so we have SDM preferred local area network based routing. That is actually it, because we got to think local area network based routing. Okay, all right, because it's doing it for local based routing. Okay. What is the purpose of configuring multiple switch virtual interfaces on a layer 3 switch? What is the purpose of configuring multiple switch virtual interfaces on a, to convert, no, to support routing between the subnets regardless, to provide reachable IP address for remote administrator, to provide layer 2 connectivity on a switch. No. Is that on a local VMware? Support routing between the subnets residing on local VLAN. All right. Let's continue. Which of the answers list the configuration step on a Cisco access switch to support IP routing using only switch virtual interfaces? Which of the answers list a configuration step on a Cisco access switch to support IP routing using only switch virtual interfaces? So 3 answers. Each VLAN interface must be configured with an IP address. The switch is enabled for IP routing. The VLANs associated with the VLAN interfaces must be configured and active. Each routed physical interface must be configured. Each routed physical interface must be configured with an IP address. You gotta select 3. Each routed physical interface must be configured. Each routed physical interface must be configured. The VLAN is associated with the VLAN interface. Let's configure and active. All right. We're doing pretty good. When you configure routing ports on a layer 3 switch, when you configure routing ports on a layer 3 switch, what do the physical interfaces act as? They act as layer 3 interfaces. Layer 3 interfaces. All right. Referred to the diagram in the exhibit, an engineer is checking the work of a coworker who is responsible for developing the router on a stick configuration on R1. Which options are true of the potential configuration on R1? Select 2 answers. So VLAN 20 gigabit 0.100, 30.200. Q shut. Encapsulation 20, 100. So VLAN 40 and 30 are actually swip swapped. Yeah, they're wrong. Interfaces handling, no, we're fine. The VLAN assignment command is no. The interface handling VLAN 30 and the assignments are convert. Yep, they're reversed. That don't matter. Will work fine as accepted. Let's look at this again. Yeah, the physical interface. You don't have to use the encapsulated .1Q. Which two steps must you perform to enable routing on a stick interface on a router subcommand? Configure the 802.1Q encapsulation for the VLAN. Yep. Configure the sub interface with IP address. Configure the IP address to route to the VLAN. Configure the sub interface with an IP address and configure the 802.1 encapsulation for the VLAN. Duplex and speed don't matter. Configure IP route to that VLAN. Figure an IP route to the VLAN. All right. Which Cisco iOS command can be used on a router to view the different VLANs that have been configured onto a router on a stick configuration? So that's the show VLANs command. Refer to the diagram. Which Cisco iOS command would be configured on router R1's gigabit 0-0.300 so that it handles all non-MAC traffic for VLAN 300, so that it would be encapsulation .1Q 300 native. All right. All right. What are the two ICMP echo? What are the two ICMP echo messages used by the ping command? What are the two ICMP echo messages used by the ping command? All right. Echo request and reply. So echo request and reply. Refer to the exhibit. What is a common cause of the behavior shown in the exhibit? Let's take a look. See. Router ping. Success. Okay, I understand that. So you see where we have the dot right there, and then the exclamation points. All right. ARP entry missing. All right. So we're pretty much ARP is doing. The ARP message went out and it's trying to receive back that layer 2 information. All right. Refer to the diagram. An engineer issues the ping 192.168.3.100 command to R1, and the ping was successful. Are there any routes? Are there any routes that would not be verified as working by the successful ping? Are there any routes that would not be verified as by the working? All right, what are we looking at? Where are we at? 192.168.30.100. So him over here. Yes, the route between PC2 and its default gateway. Yes, the route between the subnet off of R1 gigabit 0-1 interface. Yes, the route between PC1 and its default gateway. No, all routes in the network have been verified. What is this question asking me? All right. For the diagram, engineer issues the ping 192.168.3.100 command from R1. So he did it from R1. The ping was successful. Are there any routes that would not be verified as working by that successful ping? Select two answers. I guess because it's not telling me. Yes, the route between PC2 and its default gateway. It's not telling me much information here. Yes, the route. But yes, R2's route to the subnet off of R1's gigabit 1's interface. I don't have any subnet mask information. I have nothing. What are you trying to do to me, man? Yes, the route between PC1 and its default gateway. I don't know. I'm guessing at this point. I have no idea what it's trying to get at me. If I get them wrong, I would love to see the explanation. Right. Question highlights a common mistake. A ping from R1 to our PC2 verifies the connectivity between R1's gigabit interface and the rest of the network. However, it does not verify connectivity between PC1 and R1's gigabit /1 subnet. Yeah, all right, cool. Give me some more information next time. I hate questions like that. Like I gotta guess on what it's trying to ask me. The reason in this case is that the simple ping from R1 to R2 will use the IP address. Okay. Way to verify the subnet to the left, and all the other information would be to use the extended ping command and use the source IP address of the R1's gigabit. Note that the standard ping from R1 also does not test the user's default gateway setting. For instance, in this case, PC1 did not exercise its default gateway setting from. Yeah. Gamer golfer. Yeah, that exactly. That's why why I'm so upset about it. Like I didn't even care if I got this question wrong, because it's like, okay, sure, give me a little bit, just give me a slice more of information. I could probably figure it out, but nope, you're gonna be vague. This is what I'm afraid of when I take the actual exam, is questions like this if they come up on the exam. This is what I'm so afraid of them giving like super vague questions and expecting me to try to decipher what they're actually trying to get out of it. That's what I hate questions like this. All right, and so it's pretty much stating that right, it don't tell you nothing. It's not giving me any subnetted information. It's not giving me pretty much any information at all. It just says that router one can successfully ping PC2. What's wrong with everything else? Well, I don't know what's wrong with everything else. Tell me something. Throw me a bone here. Somebody throw me a freaking bone here. So yeah, so what it's alluding to is the user or the engineer should have used the extended ping command to figure out if anything else was wrong. So that's it. Like I knew. All right, let's move on from there. How you doing, gaming golfer? Good to see you. Welcome to the stream, my friend. How are you today? All right. How many seconds does the Cisco iOS ping command wait to receive a reply? That is 5 seconds, right? It's 5 seconds by default. For all we know, the end user got super drunk and forgot to plug in the damn cable. Exactamundo. Oh man, I'm tied up between 3 seconds and 5 seconds. 3 seconds, 5 seconds. I'm going with 5. I'm probably wrong. Oh, it's 2 seconds. Darn it. It's 2 seconds. All right, we're going to have to remember that one. All right, 2 seconds. The ping default is 2 seconds. Ping default is 2 seconds. All right. Which of the following troubleshooting tools can we use to help resolve a connectivity problem? So we have traceroute. We got ping. We got to select 3 answers. Which of the following troubleshooting tools can we use to help resolve a problem? DHCP don't care about nothing. CDP? Sure. Yeah, that's what I was going. I assumed it was 5. I was actually stuck between 5 and 3. 2 wasn't even in my realm of thought at that moment. But now we're gonna remember. When we think ping, we're gonna think 2. Ping 2, ping 2, ping 2. That way it doesn't leave our minds there. People, you still use CDP? Probably not. I don't use CDP. I use pretty much ping and traceroute. That's the only thing I use if I ever have to figure out anything. But what do I know? I'm just learning all this stuff. So, which protocol is used by Cisco's iOS version of traceroute command for an outgoing message? Which protocol is used by Cisco's iOS version of the traceroute command for an outgoing message? It's an ICMP. UDP. Damn it, Joe. One important thing to note when using Cisco's iOS version traceroute command that it uses a UDP for outgoing messages. This can be affected the results compared to results of a Windows host, which uses ICMP for their outgoing message. It is not possible. It is possible that feature, e.g., across the networks, can be handled ICMP or UDP differently because of that results. All right. So here's another thing for us to remember. The traceroute command uses a UDP message. A UDP message, not an ICMP message. A UDP message. UDP. All right. What are the ICMP error messages that the traceroute triggers from the router when it's generating packets? What are the ICMP error messages that traceroute triggers from the routers when it is generating its packets? ICMP error message that the traceroute triggers from the routers when it's generating packets. Time to live exceeded. Let's go with time to live exceeded. All right. Time to live exceeded. Okay. All right. Because it times out, and that's when we're seeing those trace backs when they come back. All right. Refer to the diagram. Refer to the topology in the diagram. All Ethernet links have been manually assigned OSPF cost of 4. Okay. Each end of the serial links that connect to R3 and R4 have been connected set for a cost of 15. So the serial links Instead of being a default cost of 64, they've been administratively put to 15. Okay, so they have a cost of 15. The entire private network has been configured as a single OSPF area. What is the cost from R1 routing table to reach the 10.45.0.0? All right, so what do we got? Let's make that a little bit smaller. Boop. So we have one cost of 4. Go through there. And then we have another cost of 15. And then, so remember, it's always on the outgoing interface. So even though this is reaching that 10.45.0.0 network, since it's going off that interface, it has a cost, an additional cost. So we have 4, 15, so 19, so 24. 23, I mean. Yeah, 19 plus 4, 23. Duh. All right. Which OSPF message type is used to actually send the LSAs between neighbors? Which OSPF message type is used to send LSAs between neighbors? So we have link state updates. Link state updates. OSPF enabled routers send hello packets using the which multicast address? So that's the 224.0.0.5 multicast IP address. OSPF utilizes blank to organize topology information, LSAs, link state advertisements, link state advertisements. Which LSA type describes the topology inside of an OSPF area? Which LSA types describe, so that's layer 2 and layer 1. Which types of routes will a router add to its IP routing table if the router does not use a routing protocol? So which routes would add to a routing table if the router doesn't use a routing protocol? So we have static, connected, and floating. All right, it won't use dynamic. Dynamic is a routing protocol. Okay. All right, which answers correctly describe the function and use of OSPF database description (DD) messages? Okay, the exchange counts of LSA types used after forming a neighbor relationship, but before the LSA update messages. That sounds pretty good. To exchange detailed contents of the LSAs, to exchange list identifying known LSAs used after forming relationships, but after, so to exchange list identifying known LSAs. Two internal OSPF routers connect to the same local area network, same subnet, which with router R1 acting as the designated router and R2 acting as the backup designated router. What LSAs will R1 create to flood to which ones will it flood to R2 that R2 doesn't? So that'd be, so R1, so LSA 1s are routers, router information. Type 2s are network information, and then type 3s, that is summarization LSAs. So if we had different types of areas, would be type 3 LSAs would be generated. All right, review the topology. All subnets exist in OSPF area 0. Which command if issued on R3 would show all the LSAs known by R3. Review the topology. All subnets exist in OSPF area 0. Which command, if issued on R3, would show all the LSAs known on R3? So that'd be the show IP OSPF database. Refer to the diagram in the exhibit. What is the route that is shown on R1s to reach the internet? Gigabit 0-1. 0-1. So that is 20.20.20.2. Right. For the diagram, what is the route that is shown on R1 to reach the internet? Oh, all right, here we go right here. Network 0, default information orient. Route, here it is right here. IP route 0.0.192.0.21. And is used to broadcast the route OSPF domain. Correctly, default static state route must exist initially configured. In this case, R3 has been configured with the default static route to gigabit 0-1 interface. That route meets the requirement. What did I do? That was a tough question right there. That was a tough question. Oh, I'm looking at it backwards. That's why. That's why. I was looking at it backwards. Darn it. All right. Refer to the exhibit. After some troubleshooting, you notice that the host of 192.168.2.0/24 network cannot connect to any network, cannot connect any resources, but are able to ping their gateway according to the configuration. What is the issue? So what do we got? What do we got? Interface, loopback 0, IP address. Yeah, I had the routers backwards on that one. I was looking at R1 as the router to go to the internet. When it was router 3 that was going to the internet. I looked at it completely backwards when I read the exhibit printout there. All right. So what do we got for this one? For the exhibit, after troubleshooting, you notice that the host 192, the host cannot connect to the network resources, enable the ping. All right, because that right there, because you don't have the 192.168.2 in the network. The router 10 network list command does not match the firewall's interface. Yep. The list of network commands does not match that. Which of the following rules does an OSPF router follow with regards to the selection of a router ID when OSPF process starts? Yeah, exactly. gamer golf. It was missing. It was missing an entire network, an OSPF network in there. Hey, babe. All right. Yeah, I'm almost done. All right. All right, babe. I love you. All right. Which of the following rules does an OSPF router follow with regards to the selection of a router ID when the OSPF area process starts? An administrative configured router ID is used. Nope. A default router ID. A default router ID is the loopback address. Nope. If no IPv4 address exists and if there's no configured router ID, the router creates a randomly generated. Nope. The highest IP on a non-loopback interface is the last choice of the router ID. In the absence of a specific IP, the highest IP on the loopback is used. So we got that one. All right. The administrative configured router ID is the first choice. Okay. A router configuration uses the default reference bandwidth setting and also uses OSPF cost defaults as calculated by the router. Analyzing that exhibit output for the interface serial 1, which answer lists the approximate interface bandwidth of that interface. Router configuration default reference bandwidth setting, and also uses OSPF cost defaults as calculated on the router. Analyzing that exhibit output of the serial interface, which cost pocket. So serial interface. Oh, no, I was wrong. All right. Oh, dropping stuff. All right. In the absence of a direct cost, being configured for an OSPF interface and using the default reference OSPF bandwidth, what is the cost of a fast Ethernet operating at 100 megabytes per second? So the default cost OSPF model is 19. Oh, it's 1. Man, we're gonna have to dive into some more OSPF. All right. Refer to the exhibit. Which options are true about the OSPF configuration? Up. Up. What do we have? Backup designated router. Zero. Backup designated router is 220.1 and designated router is 220. R1's file interface configured using OSPF network configuration. R2's It's configured to use single OSPF area. Configuration. Huh. I got them both wrong. Man, I am piffing it hardcore right now. If not configured with the router ID command, what is the next option? What is the next option a Cisco router uses to choose OSPF for router ID? Uses the IP of a non-active loopback. Uses the IP address of an active loopback interface with its highest IP address. Uses the IP address of a non-active loopback. Uses the IP address of a loopback with the highest interface ID. No, don't break. I thought it broke on me for a second. Refer to the exhibit. In which area would gigabit 0-0 interface be placed? Um, Placed in area 5. Which Cisco iOS command can be used to disable OSPF process temporarily? So it would be the shutdown command. Which command will configure OSPF point-to-point network type? Yeah, we were close. It was 5. Which command will configure OSPF point-to-point network type? Stuck between these two right here. go with this one. Oh, it was that one. Ah. Four OSPF routers connect to the same local area network. In a new election, after all routers have been rebooted, which router would win the election? So what do we got? So we have a priority of 4. Which OSPF command will disable the OSPF network type that a specific interface uses? Which OSPF command will display the OSPF network type that the specific interface uses? Which option does not prevent a directly connected OSPF speaker from becoming a neighbor? Which option do not prevent a directly connected OSPF neighbor from becoming a neighbor? Mismatch, subnet mask, process. There we go. Given the output from a working OSPF router, as seen in the exhibit, how many neighbor routers exist? So my timeline, I'm hoping to register for the exam by next week or so. I was just waiting to be a little bit more financially secure before I register for it, because I want to register for both the CCNA and the DevNet at the same time. Because I've done some studying for DevNet, but the fundamentals of the DevNet exam follow CCNA right behind. What I'm gonna do is, my plan is to take the CCNA and then take this DevNet associate right afterwards. So I was just waiting to have the money to afford both of them, because I want to try to register for the DevNet before the February deadline to fall in for the DevNet 2020 class. So I'm hoping by mid-February or by the end of February, I can get a date for both the exams, so I can have both of them nearly around the same time to one another. Because I already have all the DevNet study stuff ready to go, and we are nearly. No, this would be so CCNA would be my first one that I've ever gone after. Yeah, and that's why it's taken me some time, but I felt as though the CCNA was really a good one to go after first, just because of the scope, the whole scope that the CCNA covers. Thank you very much, Gamer Golf. I appreciate that, man. Thank you. Hope you're enjoying the stream. If I don't know if this is your first time here, but I try to do oh snap, good looks. Let me see what my thing said. Thank you for the follow, Gamer Golf. I appreciate that, my good friend. So if you do the exclamation point Discord in the chat, you could jump into the Discord as well. There we're going to be doing some additional type content as well. But I do stuff on Cisco Modeling Lab. We're going to be, once we get into the actual DevNet stuff, we'll be doing a lot of virtualization stuff. So I got my ESXi server where I got all kinds of VMs and everything ready to go. But yeah, man, good looks on that, man. It's totally my first time here, bro. Oh, that's awesome, dude. Thank you for coming on. Thank you for the follow, man. You pumped me up. All right, given the output of the OSPF router, as seen in the exhibit, how many neighbor routers exist? What do we got? 1, 2, 3. I'll bring neighboring routers exist. Neighboring routers exist. Neighboring routers. Let's go with 2. So we got 2. 2. All right. Let's see how we did. That was 155 questions we did. It took me some time to get through all those. All right, I'm gonna switch my cameras over too. Here we are. All right. How'd we do? Oh, snap! We got a 935. About 155 questions. We did pretty good. We did pretty good. All right. Let me close this up. All right. So, that was actually a really good exam. That was a super good review that we did today, guys. And thank you all for joining in. Gamer Golf, thank you. Maradoxbat, if you're still out there, thank you so much, my good friend. I appreciate you coming along today. BGP, Code, if you're still out there, good looking out. My other good friend, El Map, good looking out on coming in here today and joining in on some of the fun, too. It's about 9:20 my time, and I got to get ready to go to work. I got to get to work by 10 o'clock my time. Ode to Joy, working on the overnight shifts. Let me see. Screw BLSM, LOL. My arch nemesis. I tell you what, that's what actually got me today, was the subnetting questions. That's what beat me up a lot. I got to get back. You know what? I know what we'll do. We'll have to do another review on. I have the Pearson subnetting software too, so we'll have to get beat up on the subnetting software just to recap on that. But yeah, guys, this was a super awesome stream. I appreciate you all joining in today. Again, let me just do this. If you're interested. Again, if you're interested, join up the Discord. Why is everything coming in so fuzzy? Why is everything so fuzzy? Yeah, probably not. I hate working the overnight shifts. I despise it. Why does everything look so fuzzy all of a sudden? That's so weird. But let's do this. If you guys don't mind, hang out with me for 1 second. Let's go raid my homeboy. LA_LEY. Lalianda. Lalianda. You guys will like Lalianda. He's a good dude. And -23. All right, let's go raid my good friend Lalianda. Man, why is it all fuzzy? Again, guys, you guys have a great night. Love you guys, and I'll see you guys back here. I'll be on over the weekend most likely, but I'll see you guys soon. All right, guys? All right, let's go do this, guys. Let's go raid my good friend Lalianda.